Yeah, we will cover a lot of this stuff again, but for those that are here, I can kind of cover a few things, and some of this stuff might be okay to hear twice. So yeah, echoing Zach's and Austin's comments there. Definitely, if you have questions, hit the chat or comments. Use the chat. We can open it up. Probably going to try to mute everybody for now, for the most part. As we get better at this, we'll figure out other ways to do things. But yeah, use the chat, raise your hand feature. This has been approved for training hours from ADEQ. So 4 training hours ADEQ, and I don't know that we've received confirmation from ADH yet. It's very likely they will. Austin, did we receive that official confirmation from them?
I've not heard anything from Martin yet. And ADQ only approved 3 hours.
3 hours. Okay. So
I think if we next time we do, if we can cut down on break time, then maybe we can squeeze in 3.5 or just a longer session.
Sure. We will work through that. Keep in mind, everybody, in order to get, so if you still want the district to submit your hours to ADH like we've done in the past, then each organization, each city, municipality, group, whatever we like to call it, needs to fill out that training log. Have every member in your organization that attended sign it, and then email that to the district email. You could also email it to Austin or Zach or myself directly, but if you hit the district email, it'll get to us for sure. And then we'll enter your hours and kind of log them on the spreadsheet like we've done in the past. And as a reminder, of course, ADEQ does not let the district submit hours for people, but we can still track them on our spreadsheets. And then so you can reference them in the future. So we'll have a kind of a form of documentation for attendance and stuff like that. Yeah, we will be having some more announcements as we go along, and of course we'll have the business meeting right at the very end. We tried to do some shorter presentations and have more of them. It's kind of been a desire from some people in the past. We're going to try that out this time, see how it works. And a special thanks to all the presenters for helping us out this type of setting. Thanks everybody for coming. And yeah, I think it's probably about time. We're probably good to go. We can give it one more minute, I guess, but.
Hey, Mayo, I've got a few coming in the waiting room as we speak, so let's go ahead and give it another minute. Just make sure everybody gets a chance to get in.
Sounds good.
Just on a side note, with all the snow on the ground out here, doesn't that background image of the beach look real nice right now? Look at all those boats and palm trees. I don't even know what that is anymore. So
74 in Florida.
What part of Florida is that?
This is it's Miami-Dade.
Mm.
So North Miami Beach.
Looks pretty.
It is.
Well, good. Mayo, it's 8:15. I don't have anybody else in the waiting room, so Veronica, if you're good to go, let's make it happen.
Sure. Okay. Just for a reminder, I could only see my screen, my presentation. So if anyone has any questions, just please let me know. Because that's the only thing I can see. So Good morning, everyone. My name is Veronica Janessa, and I'm a process engineer for Jacobs. And today we just want to share some work that we've done regarding O&M comparative assessment for nanofiltration, lime softening, and RO systems in a water treatment facility. So this was a collaborative effort, and the people involved in this work include Carlos Carrasana, who's a plant operator supervisor, Cristina Ortega, the project engineer, and Moises Ortiz, who is the plant manager. And if you guys have any questions or want a copy of the presentation, you could either email me or Moises for it. So just a little bit of the background or presentation outline. I'll be briefly going over the background of the treatment facility, the methodologies of the cost comparisons, results on the treatment operation cost, and then going over some of the recent membrane upgrades that we've done and how that can further impact our cost reduction. I'll be talking about the maintenance and labor requirements for all 3 treatment units, and then just conclusions and benefits that we found from this work. Okay, so just a little bit of background on the facility. This is the Norwood Water Treatment Plant facility, which is located in the southeast region of Florida. It provides potable water for more than 180,000 residents. It was originally built in 1945 with a capacity of 1.5 MGDs, and this is predominantly the lime side of the plant. And then throughout the years, there's been upgrades in the lime side of the plant, as well as doing the membrane buildings, which you see over here. And then the recent upgrade that we completed, I think early 2020, was the membrane buildings, both the NF and the RO. So currently the plant has a permitted capacity of 41 MGDs, and this includes the lime softening, nanofiltration, and RO, or low pressure RO. So all treatment process can be run simultaneously with various flows, including the bypass, and this is for us to meet the average daily demand of 20 MGDs, 21 MGDs. So just a quick overview of the 3 treatment processes that we have in the plant, which makes this plant very unique since we have all 3. So first, the lime softening system. So water is pumped from our Biscayne aquifer, and then ammonia and sodium hypochlorite is added to start the production of chloramines. It goes into our Don Oliver's hydrotreater. So we have one that's 10 MGDs, the other one's 5 MGDs, where we raise the pH around 10.2 for softening and precipitation purposes. After that, it's added, CO2 is added to bring down the pH in our recarb basins before filtration. Once that, it goes to the clear well, where it then gets pumped into our blending basin, where all 3 water sources are blended. More ammonia is added, more sodium hypochlorite is added, as well as fluoride, and then caustic as well. And then it's pumped into our storage tank, which will then will go to distribution. For the membrane system, so they're pretty similar. The first one at the top is our NF. So once again, Biscayne aquifer water is pumped. It's go through sand separation to remove any fine particles to protect the membranes. It goes through, we add sulfuric acid to lower the pH to around 5.8. It goes through our micron cartridge filters to then go to our NF membranes. So there's a 2-stage membranes, and the recovery is it was 80. Now with the new upgrade, we have it's 85% recovery, and then the concentrate is disposed into the deep injection well. Once again, this goes through once it goes through our membranes, the water goes for a gasifier, which will then go down to our blending basin, which will again mix with the lime treated water and the NF and RO water. Go to storage and then pump to distribution. The RO is pretty similar. The only things that may be variants is that instead of Floridan water, instead of Biscayne aquifer, we do a Floridan aquifer. So in Florida, it's a much deeper water source. and that's why you use RO. We add sulfuric acid and go through the membranes. The one thing that's also different is that we put scale inhibitor, and the recovery rate is originally it was 75, and with the new upgrade, it's an 80% recovery. So current chemicals that are used as part of the treatment, as I mentioned, sulfuric acid to lower the pH for both the membranes, scale inhibitor, which is for the RO pretreatment, are sodium hypochlorite and ammonia to make chloramines, polymer to aid with the flocculation in the lime softening, lime to increase the pH, CO2 to decrease the pH, and any of the polyphosphates to protect our filter. So we need to add fluoride. We usually add 0.6, and this is for dental health purposes, and as well as our sodium hydroxide for the degasifier and our scrubbers. So the comparison methodology. So the feasibility study focused on chemical use, energy consumption, cost of expendables, which meant, the sludge hauling from the byproduct of the lime softening, as well as cartridge filter and any other miscellaneous cost that the three treatment had. We also looked at, we evaluated operation, personnel utilization and maintenance efforts for all three of the treatment units. So our study consisted of an 8-month evaluation where we adjusted each flow of the treatment units accordingly, and this also depended on the consumption of the permit. So we had to have a minimum flow for the RO system, so minimum utilization for the RO system. So we couldn't totally shut down one or the other. So this figure here represents the average daily finished water production per each system. So LS is the lime softening, NF, nanofiltration, RO, reverse osmosis, and this was the water production per month. So for the purposes of this work, we focused on December and January. This has been a while. So we're going to look at now the results that we got for first the chemical. So for the monthly chemical, we see that our greatest cost is our pebble, lime pebble. So this encompasses 37% of our total chemical budget. And this is because of the large amount of lime that we need to use to keep the pH above 10.2. As well, all of these costs have been normalized by the production flow of all, of the corresponding treatment units. The next highest chemical that we saw was sulfuric acid, and this is both for the membrane system, which encompasses 20% of the chemical budget, followed by sodium hydroxide, and also the sludge. It's a big cost in our lime side, and this is because we're hauling off wet sludge, so it has a lot of, liquid in there, and that accounts for the large amount of chemical cost or disposal, which we found that there's an opportunity to optimize that and maybe reduce that cost. So as you could see here, purely looking at chemical costs, once again, this is normalized by the flow. We see that the lime softening, the RO is the cheapest one in chemical cost. Lime softening is the highest cost per chemical. Now, when we look at the energy cost, we see a different story. We see that the membrane yields the highest energy cost, and this is due to the high pressure boost requirements for the feed, as well as the wells have a higher pressure requirement than the lime due to the increased discharge head that they have. So you could see here, this is wells 19 to 21. Those are your NFs, and those yield the highest energy cost, as well as your membrane building. So when we just look at energy costs, we see that lime requires the less energy treatment unit. So it's 12 cents per 1,000 gallons. Since we had a chance to play around with the flows, so when you see the first table, we have December 2018 and January 2019. So originally the lime flow was around 12.5 mgd, so we reduced it by 44%, and we increased the NF and the RO production. So with this, we saw an overall decrease of chemicals of 12% when the lime side production was reduced and the membrane production was maximized. And you could see down here, these are all the chemicals that we have that we looked for, as well as sludge and diesel. And we were able to save in chemicals for that month $22,000. So when we look at energy, once again, when we adjusted the flows, we did see a slight increase in energy costs. So originally it was 22 cents per 1,000 gallons. When we changed the flow, so increasing the reducing the lime side production and increasing the membrane production, we saw that the cost of energy went up by 23 cents a 1,000 gallons. So we lost around $8,000 that month for the energy. One thing to point out, this was the kilowatts, the amount of dollar per kilowatts wasn't consistent. It changed with the amount of energy you were consuming. So that's something that we need to evaluate further and maybe adjust for that, because it wasn't a set number. And that's just the way FP&L would give us our electricity bill. So when we do the comparison overall, we actually see that just looking at chemical and electricity costs, there wasn't that much of a significant change in cost comparison. So we decreased by 0.0 cents a 1,000 gallons. So you could see here it went from 46 cents a 1,000 gallons to 45 cents a 1,000 gallons. So there wasn't any significant cost differences. Also, when we tracked our finished water, so which I guess it's good, we didn't see any significant change. The table here are our average water parameters from pH, turbidity, color, and you can see that the standard deviation was within range, so there wasn't any outliers. However, when we take into account maintenance and I guess operation staff utilization, that tells a different story, which is a little harder to quantify as well. So when we look at preventive and corrective maintenance, we know that the lime side is a lot more demanding than the membrane side. However, do keep in mind that the lime side is a little bit older than the membrane system, but nonetheless, you have high, I guess there's a lot of wear and tear with the lime side, just because you have your slakers can clog up, even your sludge piping will eventually clog up, so you have to change the piping. There's a lot of pumps that are being failed, or a lot of maintenance that needs to be done in the pump, such as oil change and just cleaning out the tanks every 6 months. So in terms of preventative and corrective maintenance, the lime side had a lot more cost related to that. When we also look at personnel utilization, once again, the lime side is very heavy. You need a lot of people to operate the lime side as compared to the membrane side. So for the membrane side, talking both NF and RO, you could basically can have 2 people, 1 person, 1 operator at the main control room monitoring the SCADA and the entrance of the plant, and then the other person going down and taking your skid parameters every 4 hours. So conductivity, pH, pressure, and flow readings. As compared to the lime side, you need multiple operators. There's one, someone that does the backwash filters, adjusting the pH for the clarifier, and in a lot of plants, this is done manually, that you have to go change the lime dose that you're putting into your clarifier and check the pH hourly. So there's a lot of manual labor related to your lime side as compared to membrane. So we'll talk a little bit about the membrane expansion that we had and how this will attribute to additional cost reduction. So this is for the NF side. So for the NF, what we did, we all of our skids, we upgraded our skids. So we changed them and upgraded them from a 3 MGD to 3.5 MGD, as well as adding an additional new skid, as you could see here. Also, we put a new skill inhibitor addition and new feed pumps. For the RO, we upgraded the skids from a 2 MGD to a 3 MGD. Once again, the recovery rate as well increased from a 75 to 80%, as well as we upgraded our ERDs. So with this new improvements, we are expected to reduce our energy as well as chemical costs. We're looking at a pilot scale to see if we could reduce the sulfuric acid that's used in our membranes safely, as well as our NF. So we would like to continue this research and see, or work and see how we can further optimize the membrane side of the plant. So conclusion. So overall, when we looked at both, once again, chemical and electrical costs, we saw that the NF, surprisingly, I thought it was going to be the lime side, but surprisingly, the NF is the cheapest technology right now. Close, I mean, our lime side is pretty close by. So for the nanofiltration, we calculated it would be 40 cents per 1,000 gallons. For the lime softening, it would be 41 cents per 1,000 gallons. And for the RO, which is still costly, would be 47,000 gallons. The RO is the one that has a lot of energy expensive. That's because of the high pressures that you have. Your wells are a lot bigger. They're a lot deeper. I know for your membrane side, it's 200 psi as compared to your NF, which is 110 psi. So you have a lot of more energy being consumed. However, like I said, your chemical cost is greatly reduced when you increase the membrane operation. And then this is not taking into account the personnel and the maintenance, corrective, and prevention. So our recommendation for the plan is let's maximize the NF production to around 10.5, continue to minimize the lime side to less than 10 MGD. And not only is this going to save us in cost, but it's also going to provide a longer residence time. So you're going to have a longer time for any of those particulates or, to better sediments out. So process-wise, it's more beneficial. As well, we always have to keep that RO minimum flow for the RO to meet our permit requirements. So additional benefits to this is that we can better estimate our budget for not only our chemical costs, but our electrical costs. We could also have a clear view of where we can allocate budget for future projects, capital improvement projects, and also better personnel use. So we could find out where we want to invest, any of the upgrades. Do we want to do it in the lime side? For example, as I mentioned, for the sludge, do we want to try to reduce that cost over there for the sludge, or, focus on optimizing our membrane facility? And with that, I guess, are there any questions? I think 19 minutes. I have, 10 minutes for questions. So I'm going to, should I stop sharing?
Oh, you're okay to keep sharing for a bit in case somebody needs to wants to go back to a slide or something. So.
Hey, I got a question. Somebody asked, remind us, what facility were we looking at?
So this is the Norwood water treatment facility, and it's North Miami Beach.
Good deal.
So it's within the Miami-Dade County.
All right. We got any more questions in the chat? Well, I don't see any hands raised. I don't see any chat questions. So, Mayo, it's back to you.
Yeah, I think we're good. I appreciate that. Thanks, Veronica. So if anybody has any questions, then we can get you her contact information and go from there. Appreciate that. So
Thanks,
okay.
Veronica.
Yeah, let's take just a quick little break and we'll try to get Nick set up. I mean, he's supposed to start at around 8:50, but we may start just a touch before then. But yeah.
Good deal. Nick, you ready to go?
Yeah, I'm all set up and ready to go.
Cool. You want to share your screen so we can see if we can make this work? Excellent. I got it right here. Good deal. I'm gonna get some coffee. We'll meet back in a few minutes.
Okay. Yep. Thanks, everybody. We'll probably start again at around 8:45. Try to start about 5 minutes early into this next one. Thanks. Veronica, I don't know if you're still there. Looks like Chris Inlow was asked what you do with the concentrate. just a couple more minutes and we'll get started again. So I'm shooting for around 8:45. All right. Does anybody have any questions or concerns before we turn the time over to Nick? If you do, just raise your hand or drop something in the chat there. Okay. Well, Nick, if you're still with us, we thank you for taking the time to meet with us today and to provide some training for us. And if you're ready, we will turn the time over to you.
All right, thank you very much, and good morning, everybody. So my name is Nick Venditti. Let me get this going here. I am with Pulsar Measurement, so I am the Southeast U.S. Regional Sales Manager. And I hate to rub it into everybody, but I am also located in sunny Florida. So I'm presenting out of the Tampa Bay area right now. And I'm happy to have been asked to present today by our municipal representative in Arkansas and Western Tennessee, Jack Tyler Engineering. So they've got a couple locations there in Arkansas that can service you with our Pulsar measurement products. So today what I'm going to cover, Pulsar Measurement, we specialize in ultrasonic flow and level instrumentation. And today I'm going to just specifically present on our clamp-on flow meters. And so just a little background on Pulsar Measurement. You probably may not have heard the name Pulsar before, but you may be familiar with the company Grayline Instruments. And so that's actually the company that I come from. And Grayline Instruments was purchased by Onicon, which is an HVAC focused company back in 2014. And then they also purchased a company called Pulsar Process Measurement back in 2018. Pulsar Process Measurement primarily focuses on ultrasonic level, and Grayline did ultrasonic flow and level as well. So there was so much synergy between Grayline and Pulsar Process Measurement that they decided to integrate both of the companies into one. And so we are now Pulsar Measurement. So that's the combined companies there. So like I said, you may be familiar with Grayline instruments in the municipal market. You can check out our new website there. We got new logo, new name, new branding, the whole 9 yards, but we still have the same legacy instrumentation from Grayline. So I always like to start out our presentations with this slide. Why should you consider Pulsar Measurement flow and level over competitors? And it's because we're easy to use, easy to set up, easy to install. We use this nice 5-button keypad, very easy menu layout. And the nice thing is, if you've used one of the legacy Grayline meters, then you're familiar with the layout of all of the meters because it's a similar layout to the other instruments. We have reliable performance. We manufacture our own piezoelectric crystals. We manufacture our own printed circuit boards. So we have very good quality control over our products. Management of information. So all of our units come standard with a data logger, and we provide free software to analyze that data logged information. We're economical from a product cost and installation and over the life cycle of the unit. And we're very responsive. So typically the Pulsar Measurement inside sales team or anybody on the team, we're responding within 24 hours, and we can get all of our products shipped out of our factory typically in 3 to 5 business days. And with the merger of both companies, we now have 2-year warranty on all of our products. So here's just kind of a general lineup of what we offer. Again, these are from the legacy Grayline side of Pulsar Measurement. And today we're just going to focus on these clamp-on ultrasonics, the transit time and Doppler flow meters you see on the left. So we're going to jump right in with our TTFM 6.1 transit time flow meter. And so some of you may be familiar with transit time already from some other companies, but the basic way these operate is we have 2 transducers that clamp on the outside of the pipe. And what they're doing is they're sending an ultrasonic signal back and forth to each other. So in this diagram on the bottom right, you can see the A transducer is sending a signal across the diameter of the pipe, bouncing off the pipe wall, and then transducer B is measuring that or receiving that transmission. And then transducer B is doing the same thing in the opposite direction. Now, if that pipe is completely full and there's no flow in it, those signals are going to take the same amount of time either direction to arrive at the opposite transducer. But as soon as we introduce flow into the system, the signal that's moving with the flow is going to arrive faster than the signal that's going against the flow. And so what this unit is doing is it's measuring the difference in that transit time of that signal, and that transit time difference is directly proportional to the fluid velocity. So that's generally basic background of how we're making this measurement with the TTFM 6.1. So what are some benefits of the TTFM 6.1? So the biggest benefit is that we're non-invasive and non-contacting. So these transducers clamp onto the outside of the pipe. They don't require you to stop the process fluid. You don't have to cut the pipe. You don't have to weld any flanges. You don't have to weld any ball valves onto the pipe. So the installation, like I said back a couple slides, the installation is very easy. It doesn't require any specialized equipment or any specialized technician to come out and do the installation. Our inside team, if you're having trouble figuring it out on your own, we're happy to walk you through it on the phone. but very easy installation, especially when you're coming from the municipal side. I know the CDC had reported, you know, that with COVID, it's been traced in wastewater. So to be able to do these types of flow metering installations without having to come in contact with any of the fluids on site is also a big safety concern. So these are used specifically for full pipe flows in relatively cleaner non-aerated fluids for the TTFM 6.1. We recommend 15 pipe diameters of straight run. So typically it's 10 pipe diameters upstream of the transducers and 5 pipe diameters downstream of the transducers. I know that's not always feasible. And so I like to tell people that this is a recommendation and not a requirement. We can absolutely, in the majority of applications, get a accurate and repeatable flow measurement in less than ideal straight run applications. As you can see here, we have both a permanent wall mount version in the upper right, and we also have a portable unit there that's in that nice orange Pelican case. The portable unit is an excellent tool, especially for municipal water, wastewater treatment plants. This unit, you know, we sell this a lot as a diagnostic tool for wastewater treatment plants or water treatment plants. You know, you have a mag meter that's in line there and you're questioning its flow rate and reliability. You can literally use this portable unit, strap it onto the pipe, you know, just upstream or downstream of the mag meter, and be able to track the flow rate and see how well they're matching each other. The unit itself is able to handle a wide variety of pipe sizes and materials. So in a few slides we'll see, but the TTFM 6.1 can handle pipes from 1/2 inch diameter all the way up to 48 inch. The portable right now is 2 inches to 48 inches. And then we have a wide range of process fluid temperatures from -40 degrees Fahrenheit all the way up to 300 degrees Fahrenheit. And then with the 6.1 generation, we've greatly improved the accuracy, the performance, stability, noise immunity, and we've included a lot of onboard diagnostics for troubleshooting. So using the TTFM 6.1, it's a very easy setup. One of the questions I get quite a bit is, well, how far apart do those transducers need to be on the pipe? And there's not a set distance that they have to be. It's all going to depend on the information that you plug into the setup menu. So the 2 screen grabs that are on the left-hand side here are from the setup menu of the TTFM. And so essentially what you're doing is it's asking you what fluid you're measuring, you know, what's the average temperature, pipe material, outside diameter, wall thickness, is there a lining, crossings, which I'll get into that here in a couple slides. And then the unit, based on that information, is going to tell you what that sensor spacing needs to be. You can see it there right above the velocity measurement on the bottom left picture. It says sense space. So that's the calculated sensor spacing based on the information programmed above. Rule of thumb is the sensor spacing in the mounting method you see in the upper right. The sensor spacing is going to be less than the diameter of the pipe. So it's just kind of a good rule of thumb. You can see here in the middle, that is a picture of the main display. So you get your volumetric flow rate right there in the middle. You have your units of flow in the upper right. You get a totalizer. You have your relays on the bottom. The little black square around the number 1 just indicates that relay is energized. And then we have a couple of diagnostic icons in the upper left-hand corner. So I mentioned that we have a wide range of pipe diameters, and we accomplish that by using different transducers. So our TTFM 6.1 traditionally only had these standard B sensors that we see in the upper right-hand corner there. And they're spec'd for 2 inches up to 48 inches. And we'll see here in the next slide that we expanded our transducer offering because of different mounting methods that we have. So one area that we were missing was pipes under 2 inches. So last year we released our small pipe or A sensors, which are capable of measuring on pipes from 1/2 inch to 4 inch diameter. We typically recommend them for 1/2 inch to 1.5 inch pipe diameters. And then we just recently, the beginning of this year, released our large pipe or C transducers, and they're good for 12 inches up to 48 inches. And so you may be wondering, well, we already have B sensors that are good up to 48 inches. Why do we have another set of sensors that's good up to 48 inches? I'll get into that here in the next slide. So we have a few different transducer configurations. So the default mounting method is this V mounting or 2-cross. So this is what you've seen depicted in all of the TTFM 6.1 pictures I showed up to this point, where both transducers are on the same side of the pipe. And what's happening is the signal is going across the diameter of the pipe, bouncing off the pipe wall, and then reflecting up to the other transducer. This is the default choice because it's the easiest installation mount for customers. The only thing you have to do is measure that horizontal distance between the 2 sensor faces to get them mounted on the transducer or on the pipe. And then this also gives us some flow averaging because that signal has to cross the flow diameter twice. And so then we have the Z mount or the 1-cross, which you see here in the middle. So this is the second choice if we're getting a low signal in the 2-cross mounting. And that may be due to some turbulent flows. That may be due to some scaling on the inside of the pipe if it's an older pipe. It's just a way to increase the power of that signal because now it doesn't have to reflect and cross the diameter a second time. But this mounting method is much trickier because not only do you have to measure the horizontal distance accurately, but you also have to rotate one of the transducers 180 degrees around the pipe opposite the other transducer. So it's a much more difficult mounting method, especially when you start getting into larger pipes. So that is why we released the C transducers, the large pipe one. So even though they have the same upper pipe diameter limit as our standard B transducers, the C transducers allow us to keep using the 2-cross or V mounting method in larger pipes. Traditionally with our B sensors, once we got over that kind of 20 to 24 inch diameter pipe, we'd have to go to the Z mounting method because there just wasn't enough power in the transducers to get that bounce across the pipe and keep a strong signal. So the release of these large pipe transducers allows us to keep this V mounting or 2-cross method in larger pipes up to 48 inches. So it just makes it easier for the customer to do the installation. And then we also have this W mounting method or 4-cross, which is for small pipes. So there may be some times where you're using the small pipe transducers and you program it in the unit for 2-cross and the sensor spacing actually comes up negative. That would mean the sensors have to overlap each other on the pipe, which isn't physically possible. So we go from 2-cross to 4-cross and it just adds an extra bounce in there to push the transducer out a little bit to give you a positive sensor spacing. I mentioned in one of the first slides our management of information. So with the release of the TTFM 6.1, we made our data logger standard. This used to be an optional feature in previous generations, but with the 6.1 generation, that's going to be a standard feature now. The data logger has a capacity of 26 million data points. So even at its fastest data logging interval, you'll be able to log like just under 9 years worth of data. So you won't ever run out of data on this unit. And you can see the USB ports mounted right there on the front panel. It's behind the polycarbonate enclosure. It's nice because it doesn't require you to press any buttons to download the information. You just open up that front cover, put the USB stick in there, and it automatically starts downloading it to your thumb drive. We have two options for downloading the information. We have a gray line logger software. So you can download it in this .lg2 format, which is compatible with our software, or you can select to download it directly as a CSV file to open it in Excel. We have some diagnostic information in like a special tech menu. If you're having any troubles, we can download these special waveforms so we can actually see the acoustic echo and how it's performing in the pipe. And so it allows our tech support team to analyze that to determine if there's some noise in the system or if the setup's incorrect. We can pull that information from the USB. There's a 24-hour log that we can download there, and we can also do firmware updates. So if we release a new version of the firmware to fix a bug or add an additional feature, and you want that feature, then you can email us. We will email you the firmware, and you put it on a thumb drive, pop it in there, and it automatically starts downloading it, and you just power cycle the meter for that to take effect. So we've added a lot of functionality to the USB port there in the front. So some standard features and specs of the TTFM 6.1. So to go back, so this is for clean fluids, clean liquids. Our spec is less than 2% solids or gas bubbles. I personally have seen this work on fluids in the 5 to 7% solids range and work reliably and accurately. There's actually an application here in Tampa where we hooked this up to a 48-inch raw wastewater line that was entering a treatment plant, and we were getting 100% signal strength and matching the flow rate that they were expecting. So this unit can handle a significant amount of solids. We spec it at 2%, but it can definitely handle some more than that. Standard enclosures, NEMA 4X, IP66. Accuracy is plus or minus 1% of the reading between 1.5 feet and 40 feet per second. If you're under 1.5 feet per second fluid velocity, then it's plus or minus 0.02 feet per second. Standard power is 100 to 240 volt AC. You can get it optionally as a 9 to 32 volt DC if you have a remote application, want to hook up a battery and solar panel system. Has a standard 4 to 20 output, which can be converted to 0 to 5 volt output. Has 2 control relays, which can be programmed for high flow, low flow alarms or pulse output. And we can also add an additional 4 relays to give you 6 total. We can run up to 500 feet of cable length between the transducers and the display. We have class 1 div 1 intrinsic safety available, and we also have Modbus and HART available for serial communications. And then just to give you kind of show you a little bit of difference between the portable, the PTFM 1.0 and the TTFM 6.1. So the portable unit has a built-in rechargeable battery. It can operate continuously when plugged into a charger. The data logger is only 300,000 points on the portable. It's only compatible with the B sensors right now, which are 2 inches to 48 inches. You don't have any control relays, but you do have a 4 to 20 milliamp output on the portable. We are in the process of updating the portable to the 6.1 generation. And we're actually looking to release that new portable, it looks like in April. So it'll become the PTFM 6.1. And so what you'll see is it'll be compatible then with the A, B, and C transducers. It's going to get a larger data logger. And it's going to be, right now our portable unit, the handheld portion does not have any IP rating on it. But we're going to go to, I believe, either IP66 or IP67 on the control unit on the handheld portion of the portable with the 6.1 generation. So it's going to be a more robust unit and have more of the features of the TTFM. And here's just a quick little screen grab of to give you an idea of the battery life. So you can go anywhere from 18 hours on a 10-second logging interval up to 20 days of continuous measurement on a 5-minute interval. Again, if you have it plugged into its charger, you can operate it continuously. This is just if you're using just the battery there. So we're going to move on to our Doppler flow meter. So our Doppler flow meter is our other clamp-on ultrasonic, and we actually are the industry leader for Doppler flow measurement technology. A lot of competitors have Doppler, but they've stopped innovating on it. They are, focusing all their efforts on transit time. This is really where Grayline had built their brand recognition with this unit, and we continue to develop it to this day. So this unit is, you can see there's only a single transducer that gets mounted on the pipe here. So installation is much easier than the transit time. You don't have to worry about sensor separation or anything. It's just one transducer, it clamps on the pipe. This is designed for complex or difficult fluids that have suspended solids or are aerated. And the way this makes a measurement is that single transducer on the pipe excuse me, has two sensors in it, or excuse me, two crystals in it. It's sending a sound wave into the pipe, and then the other crystal is listening for the reflection of that signal off of particulates and air bubbles in the flow. So this uses the Doppler effect. So moving particles and air bubbles in the flow are going to change the frequency of that reflected sound wave. So we're actually measuring the difference in frequency of what we send into the pipe and the reflection we receive off particulate in the flow. And that frequency shift is directly proportional to the fluid velocity. Because this is for full pipe flow, we then know the cross-sectional area of the flow and can calculate, the meter then calculates your volumetric flow rate. So you can see there, we have a picture on the bottom of the DFM on a ductile iron pipe. And both of these units are good on essentially any type of piping that's rigid. Can do ductile iron with cement lining. We can do HDPE, PVC, stainless steel, carbon steel, pretty much anything as long as it's rigid. So again, unit is non-invasive, non-contacting. This is designed, like I said, for those difficult fluids. So your raw wastewater, your return activated sludge, those are definitely fluids that you don't want to come in contact with. Processes that you don't want to shut down. So again, you don't even have to stop the process to mount these. You can have the fluid moving in the pipe, and both of these units, the DFM and TTFM, you can mount and install without having to stop the flow in the pipe. So that's a big advantage. Again, we do have a portable version available. The PDFM 5.1 looks almost identical to the portable transit time. Same packaging, it's just, uses the Doppler sensor instead of the transit time. Again, wide variety of pipe diameters. And this single transducer can handle pipes from 1/2 inch diameter up to 180 inches in diameter without changing the transducer on either the portable or permanent versions. So that really gets economical when you start getting into larger diameter pipes. Both units, transit time and Doppler, we've had customers where a mag meter goes down in a pit and they don't want to stop the process. They don't want to replace a $20,000, $30,000, $40,000 mag meter, and they just go down and install either the Doppler or transit time, depending on the application, right next to it, and they're up and running for under $3,000. Standard features and specs looks pretty similar to the transit time. It's just the percent solid range. So remember, with the TTFM, we're spec'd at 2% solids or less. For the Doppler, we're spec'd at 2% solids or more. There is overlap between the two units. So like I said, I've seen the transit time work on fluids up to 5 to 7% solids. So there is going to be some areas and applications where you can get both the DFM and TTFM to work. And sometimes it's just a matter of testing the unit out at the application to see how it works. But for the most part, you're looking at your dirty fluids with suspended solids, aeration, sludges, slurries for the Doppler. This is a plus or minus 2% of reading unit as opposed to the transit time, which is plus or minus 1%. But you still get the 4 to 20 output, 2 relays, optional additional 4, 500-foot cable length, class 1 div 1, and optional Modbus or HART serial communications. Again, with the portable, you get the same, it's the same battery life as the portable transit time unit, but again, it uses that single transducer for 1/2 inch to 180 inch, same data logger and same no relay, but you do get a 4 to 20 there. And one other unit I wanted to touch on briefly is our Doppler flow switch. So this is the DFS 5.1. This uses the same sensor as the DFM 6.1 that we just talked about, except this is just essentially an flow or no flow switch. This is a great unit for pump protection. So you can mount this, I mentioned before, ideally we're looking for that 15 diameters of straight run for the transducers. That's with both the DFM and TTFM. With the DFS, we're not so much concerned about that because this isn't measuring flow. It's not measuring it and recording it. It literally just wants to see if we get a repeatable flow signal, and then you can set a high flow or low flow alarm point. And once the flow gets above or below that set point for however long your delay is set for, there's a simple control relay that sends a signal out. So you can either use that as an alarm to a SCADA system, you can use that to cut the power to a pump so you don't run it dry, whatever. But for under $1,000, you have a very reliable pump protection here with our Doppler flow switch. And so just to touch on some typical applications for these units. So with the transit time, we're typically looking at raw water, so lake, stream, river, etc., cooling water, chemicals, low conductivity water, water and glycol solutions, diesel and fuel oils, treated water, and domestic water. For DFM, we're looking at raw sewage, combined sewers, municipal influent, viscous fluids, return activated sludge, slurries, pulp stock. So you can see, the different territories that they cover. But again, there can be some overlap between the two depending on the application. And just to bring it home, like I said, I like to start and end with this slide. We really push pulsar measurement because we're easy to install, set up, and use. We're reliable performance from design to manufacturing and operation at the site. Our management of information with our standard data logger and free software. We're economical, so both the transit time and Doppler. It doesn't matter if you're measuring a 1/2 inch diameter pipe or a 48 inch diameter pipe. There's virtually no difference in the price of the unit. So that's a great way to compete against the inline mag meters or insertion mag meters or anything like that. We get that economy, especially when we get into larger diameter pipes. We're very responsive, whether it's coming from us at Pulsar Measurement or our rep partner, Jack Tyler. We're very responsive to questions, and we typically get everything shipped out in 3 to 5 business days. And again, our standard 2-year warranty on all of our products. So, any questions, comments, concerns on any of those instruments or that type of flow technology?
Hey, Nick, there are a couple questions in the chat there.
Sure.
The first one asks, will the surface of the pipe cause a problem with the accuracy of the measurement? And do you need to use a gel between the sensor and the pipe surface?
Great question. So yeah, if it's an older pipe and it looks like it has some rust or corrosion on it, or even maybe, I know some pipes come with like a very thin coating of paint or something like that. We usually recommend, scraping it down to the surface of the pipe to give yourself a nice clean contact with the pipe wall. And yes, we do have a coupling compound that we provide with all of our clamp-on flow meters. So you just put a little bead of the gel on the face of the sensor when you mount it. We are actually looking at moving to a gel pad here probably, middle of this year. It'll be something we can offer alongside of the compound. So it's literally a gel pad that kind of sticks to the face of the sensor, and then you can put it on the pipe. Because there are applications where these transducers are outside in the weather. The coupling compound we provide already does hold pretty well in the weather, but obviously it's not going to hold forever. So you may have to periodically replace it. With the gel pad, we'll be able to last even longer in those environments where we're outdoors exposed to the elements.
Good, thanks, Nick. A couple more questions we see on there. Veronica asked, what is the accuracy between the V, W, and Z mounting configuration?
So the accuracy does not change based on the mounting method. It's really just a way to make sure. So with the transit time, we're always looking to get 100% signal strength. So those different mounting methods are just different tools in our back pocket to get us that 100% signal strength. So they're not going to affect the accuracy at all. Again, with the 2-cross, we are getting some flow averaging because it's crossing the diameter of the pipe twice, but it's not going to give you any kind of significant advantage over, let's say, the 1-cross where it's only crossing the diameter once. As long as we're getting that 100% signal strength, that accuracy spec is going to hold for any of those mounting methods.
Thanks, Veronica and Mike. Let's see, got one more question here. Someone from Jack Tyler asked if you could hit on the area velocity flow meter, manta ray, on diagnosing flow combining into a pump station or coming into a pump station or manhole.
Sure. So we do have another technology and that we have. It's an area velocity flow meter. If I don't know how much time we have left here, I say I could pull up a couple images of it so you can see what it looks like. So the area velocity flow meter is a unit that can be used to measure flow in open channels or partially full pipes that do not have a flume or weir installed. So I'd really like to just show a picture of it quick if I can. All right, can you guys see that now?
I cannot see it, but
oh, sorry. I guess I
not sure.
share.
There.
How's that? So can you guys see that now?
Yeah.
Okay. So this is our AVFM 6.1. So this uses this submersible transducer here. So you can see there's a crystal in the top of the unit and 2 crystals in the front. The one on the top is going to measure the level of the fluid, and the one in the front is going to measure the velocity of the fluid. So like I said, this is used for partially full pipes, open channels. So you can use it in, the effluent leaving a wastewater treatment plant. You can use it for water coming in through the sewer lines into lift stations. And so we're measuring the level of the fluid and the velocity of the fluid in the unit itself. You're just programming in, what the channel dimension is. Are you using a circular pipe, a rectangular channel, trapezoidal? We do have the ability to build custom channels inside the unit. And it uses that information along with the measured velocity and level to give you a volumetric flow rate without having to have a flume or a weir. This is the permanent version, so wall-mounted unit. We do have a portable unit of this. It's called the Manta Ray, and it looks kind of similar to the PDFM and PTFM, where it's in that nice orange Pelican case, but it's actually built a unit that's built into the Pelican case. Has all the same features as the AVFM. It's just built into a waterproof case and has a rechargeable battery, but uses the same transducer.
Great. Thanks, Nick. We really appreciate it. So looks like that's all the questions for now. If anybody has any more, they can hit them in the chat and we can get contact information. And thanks, Jack Tyler, for helping out as well. Appreciate
Thank
it.
you very much, everybody.
Let's just take a quick 5-minute break and we'll start up again at 9:30. We will get John kind of set up and rolling, and we'll see you in a few minutes.
John, are you ready to rock and roll?
Yes, I am. Can you hear me okay?
I can hear you great. You want to try to share your screen so we can make sure this works?
Sure thing. Let's see here.
Oh man, look at that. Is that what you look like, John?
No, I just, that's a picture of a model I just put in there. I don't want anybody to see what I look like.
Well, good deal. All right, I'm gonna go get some more coffee. We'll get back in 5 minutes.
All right.
All right, everyone, just one more minute there, and we'll get started here in just a minute. Okay, I'm showing 9:30. Just a quick comment there. If anybody has any changes they would like to make us or encourage us to adhere to for the next Zoom meeting and training session that we do, we haven't not announced that date yet. We wanted to make sure everything went okay here, and seems to be going pretty well in my opinion. But then we can make some changes and adjustments and maybe scheduling things down the road here. We'll keep you guys informed via email, but if anybody has any comments or suggestions, feel free to leave them in the chat or send an email to the district. We'll definitely take those into consideration. So with that said, John, if you're ready, then we'll thanks so much for helping us out, and we'll turn the time over to you.
Oh yeah, well, thank you very much. Good morning. I hope everybody's weathering the storm, so to speak. It's got to be tough for you guys. Anyway, thanks for coming to this presentation. I'm John Scala, Municipal Sales Manager. For about 32 years, I've been with Zurich, so seen a few valves in my day. It's been a couple of years since the last time I presented at one of your meetings, so I'm happy I could come back for another one. Today, I'll briefly discuss some common types of valves found in wastewater and water treatment. Those include eccentric plug valves, AWWA butterfly valves, and check valves. I've been given a half hour to discuss these topics that could easily take a whole day each, so I'll be moving quickly. I should mention that this is intended to be educational and not a sales promotion. There are a lot of our own pictures, but I'm only using what I had available. When it's time to select a valve for your application, there are a number of things to consider. What has worked or what hasn't worked before, what's flowing through the valves, and what's important to you. Reliability, ease of maintenance, cost for pumping, energy cost, purchase price, and so on. There is no one valve that handles every application, but we'll look at a couple of them. So let's go ahead and get started. We're going to start with eccentric plug valves. They're one of the oldest type of valves still used in the wastewater plants today. The original eccentric valve was invented in the 1920s by Matthias de Zurich, right here in Sartell, Minnesota. There was a need to shut off reliably against paper stock. And paper stock is fibrous. It can stick and foul up in many types of valves. The gate valves that they were using were cutting it. So the plug valves are used. Wastewater has the same problem, and eccentric plug valves quickly became and are still the solution in wastewater. We'll take a look at differences among the eccentric plug valves that are available. Most notable differences among brands are port shape and size and the methods of sealing the stem. And like I say, there's plenty of other things we can talk about. I'm just trying to hit the highlights. But it is important to understand how an eccentric plug valve works. The resilient plug face, and in this picture, it's the red curve. The plug you can see is in the center of the valve body, and the red curve is the rubber covered plug face. So that plug face is machined to a different center line than the valve shaft. And that offset causes the plug to only touch the valve body seat when the valve is fully closed. And the body seat is what's depicted in the yellow color. It's in the valve body, so when it's closed, the red seat and the yellow body seat will meet each other. And I'll just show you with a couple clicks here to show you what it looks like. So right now the valve is open, nothing's touching, the plug is stored out of the way, out of the flow path, and media, whatever it may be, if you think about what's in sewage, is flowing to that valve. Now the valve is going to move partway closed, and you can see that it's starting to shut off the flow, but you'll also see that there is no contact between the plug and the seat. That's the eccentricity. And then finally, when the valve is closed, you can see that now the plug and the body seat touch each other. So if you think of, what's in wastewater, potentially sharp and hard particles that can be in raw sewage, rubbing could ruin the valve. And that's why eccentricity is so important. And because of the not rubbing, eccentric plug valves are known to last for decades in these applications. So what else makes an eccentric plug valve work? Well, it's the raised nickel seat. The seat is raised to allow for solids to be pushed out of the way when the plug closes. If the seat weren't raised and it was just flat plug pushing against the flat valve body, you'd start to create kind of a compaction, and you'd build up and the valve would start fouling up, it wouldn't work. So the raised seat prevents that. The material is nickel, which is very corrosion resistant. It's also hard, and it prevents abrasion and wear. It's also non-porous, so you can machine it very smooth so that the rubber has a smooth landing on the seat, and also minimizes wear there. And on rectangular ported valves, the seat, regardless of valve size, is a 1/2 inch wide and 108 inch, or 1/8 of an inch thick. Excuse me. Anyway, now looking at the form factors of eccentric plug valves, we talk about the port shape, round port or rectangular port. The port is just a result of what the plug is shaped like. So a rectangular ported valve has a cylindrical shaped plug. It's only curved on one plane and it's flat on the other plane. So all you have to do is rotate the valve to create closure. Pretty simple design. And so it creates a tight seal just by rotation. Round ported valves are due to the plug being spherical shaped. Okay, it's more like a ball, a segment of a ball. For those to shut off, the valve is rotated, like all eccentric plug valves, but it also needs to be centered axially. It's necessary to keep the round plug in the center of the round seat to create a good seal. One thing to note, because of the shape, the plug will touch and continue to rub the seat for the last 1/4 to 1/3 of travel to close. So there is some contact before it gets all the way closed. So that's one difference in functionality between the rectangular and round. Port area options. So for decades, standard port existed. When Matt Nazarick invented the eccentric plug valve, he needed it to fit in the same space as a gate valve. And so he found out that he could get everything he wanted accomplished and fit in the same space if the port was 80% of full pipe. Remember, they didn't have high flow velocities, a lot of abrasives, a lot of solids. Energy costs weren't so important. So that is what he came out with, and that's still the most popular port design. It's 80% or more for 20-inch and smaller valves, and 70% or more for larger sizes. And that's anybody who makes a rectangular ported valve. Those are the dimensions that we follow for standard port. It is the original do-everything valve. It just simply shuts off every time with clean or dirty media. And incidentally, rectangular ported plug valves are great for control. If you wanted to control flow or pressures and so forth. 100% port valves, they actually are designed to fit in the same space and they have the same features as the standard port valve, but the port area is a full area as much as the pipe. And so think of more energy efficiency. They're great for handling solids and especially abrasives, which can be an issue when you're dealing with grit and so forth. So 100% port's a good choice there. And just one note, by the way, round port eccentric plug valves are not available in 100% port area. Okay. Like I say, there's plenty of things to cover. I'm just hitting the high points, but packing might not seem like a big deal, but until it's leaking and makes a mess, then it is a big deal. There are two types of packing used on eccentric plug valves. Multiple V-ring packing is most common, as you can see in the picture. It has a set of inverted V-shaped rings and a gland follower. When pressure inside the valve increases, the V's spread and prevent leakage. But that makes sense when there's a lot of pressure. When there's not a lot of pressure, we still have the V-rings spread. We actually preload the gland follower a little bit so that there's always some force acting on the rings, and even at low pressures, they seal tightly. So it's good for high and low pressures. One of the things to notice is any valve that utilizes a V-ring packing always has a space between the actuator and the valve top. That way the packing can be inspected. You can adjust it, or if you want, even replace the packing without pulling the actuator off of the valve, which means you can leave the valve in service while you're doing it. One thing to note is the picture way on the far right, there's below the red circle, below the cover, there's a white washer. It's really a thrust washer, but it also serves as a primary seal for dirt from getting into the bearing and the packing area. And it does allow for replacing packing even if the valve is under pressure. So that capability exists. Let's see here. Now, if you look at the other type of packing, there's U-cups. There's usually two of them stacked, and then they have an O-ring filler inside each ring. Now, typically, this is a seal you use in linear applications like piston seals. However, some valve manufacturers have been using them in their rotary motion eccentric plug valves. U-cup packing is used in valves that do not have a gap between the valve and the actuator. And as I mentioned, it doesn't have the advantage of inspecting or adjusting it. And to replace it, you actually have to take the valve out of service first and then remove the actuator to be able to access the packing and replace it. Okay. So in regard to typical applications, just some things to consider. And I should say many owners standardize on one type of valve for everything. Others will pick the valve according to the application. If there are concerns with abrasive media, such as grit or sand, 100% port is ideal because the fluid velocity doesn't increase as it passes through the valve. It minimizes the sandblasting effect that can happen at high velocities. Likewise, energy costs are important for pumping. 100% port has less head loss and also keeps the flow straight as it enters the pump on the suction side. For flow or pressure control, a standard port is the best choice. As a matter of fact, rectangular ported eccentric plug valves are among the best performing control valves available for wastewater. They handle a broad range of flows and are very resistant to causing cavitation. Digester gas is a special application. Hydrogen sulfide and methane in that gas can pose problems. Hydrogen sulfide can be very corrosive. Proper selection of materials are important. Aluminum is chemically inert to hydrogen sulfide and is a popular choice for valve material for digester gas. Another option is to use a stainless steel plug in the iron body that the valve normally has. The stainless steel plug will eventually get rough over time, but it does last a long time and it's a good material. Methane gas, its problem is it's combustible. It does require the valve to seal tightly and to stay shut. We recommend you always using a worm gear. It holds the valve closed, even if it were bumped. Unlike a lever, if you bumped a lever and you knock the valve open, then you got methane gas going down the line. Also, we recommend a special test where low pressure air is used to prove that the valve seals even at low pressures, and we know digester gas is usually at low pressures. Okay, that was just a real quick look at the eccentric plug valves, and you know, feel free to type questions in the chat if you'd like or ask them. But we're going to move on to the AWWA butterfly valves now, and just rule of thumb, eccentric plug valves can be used in clean or dirty fluids. They're kind of the go-to valve in wastewater. AWWA butterfly valves, or any butterfly valve for that matter, are used in clean water and air applications. They do have an advantage of being smaller and lighter, and maybe even less expensive than other valves of the same diameter. They can be a control valve. You know, they're not necessarily a do-everything valve, but they can be a control valve. But you need to take care, because you wouldn't want to do a high demand control application, such as a broad range of control from the min flow to the max flow. And you wouldn't want to have a high pressure drop, because they are prone to cavitation. I would steer you back to another type of valve, such as an eccentric plug valve, if you had that application. And so the greatest differences among the brands are in the seat design. So that's kind of what we're going to pick on. Where's the seat located, and how is it retained? So if we look at these two pictures, you can see there's two different types of design, and we're just talking about the small diameter at the moment. AWWA C504, the governing standard for these valves, require valves 30 inches and larger to have adjustable replaceable seats. For 20 inches, 24 inches and smaller, seats can be permanently bonded or clamped into place. My understanding of most valve manufacturers is that if they're going to go to a different design, it usually stops at 20 inch and then a different design at 24 and larger. So that's how I'm presenting it. One way to put a seat into a butterfly valve is to vulcanize it in. It's a bonding process using heat and pressure to make a permanent bond, and that bond is stronger than the rubber itself. And you know, there's methods of testing it to prove that out. So on the picture on the left, you can kind of see that the valve has the rubber that's permanently bonded to the valve body, and it's not going to pull loose. It's not going to come loose. It's not glued in. It's bonded. The other way is to clamp the seat with fasteners, like shown on the right. It's removable, but it's not always practical to work on seats of this size. You know, it should be noted that to repair or replace a seat in a small valve is not cost efficient. It's usually less expensive to purchase a new valve and then quickly swap them out. The other thing I want to point out is seat location, and that varies among brands. It's most popular to have the seat in the valve body. It's generally believed that the seat has more protection from the high velocity flows, and no matter how clean we think our water is, there still may be sand or whatever particles or construction material or whatever in the line that still could flow through the pipe. And if the seat is on the disc edge, which is in the middle of the flow, it may be more vulnerable to damage. So, but that's two different types of philosophies from various manufacturers. Now, there's more to talk about on the larger diameter valves, 24 inch and larger. And like I say, most people start at 24 inch. The first method to put a seat in a larger valve is to clamp it in place, either in the body or the disc. And I explained a minute ago about the differences between seat and body or seat and disc. Those seats are adjustable only if the flat side of the disc is on the downstream side of the valve. That's because the valve must be closed with pressure on the opposite side of the disc, so the leak can be seen. You know, you have to be inside the pipeline to see it, and the proper screws are tightened. The second method is to lock the seat in the valve body. And I should mention all of these are mechanical. Nothing is glued in place or anything like that, even though we use the word epoxy. The seat is locked in the body, in the valve body. There's a dovetail shaped groove in the body, and then the rubber is put in, and a filler of hard epoxy is added behind the rubber, and that locks it in place. An advantage to this design is it's adjustable from either side of the disc. What that means is you can install the valve in the preferred position. In other words, the flat side of the disc can be upstream. And one thing to bear in mind with that is when the valve is installed in the preferred position with the flat side upstream, the operating torques during operation are substantially lower, significantly lower on big valves. That puts less strain on the actuator, puts less strain on the valve shaft and connecting parts. So, you know, especially on larger diameter and especially with higher flow rate velocities, that's important to consider. All right, that was pretty quickly through the butterfly valves. Now we're going to look at check valves. And here we go. So check valves are, of course, very simple mechanical devices. They open when the upstream pressure exceeds the downstream pressure. In other words, the pump side of the valve, when it gets higher than the system side of the valve. That's when the valve opens. And they'll remain open as long as there's flow. When flow stops, the check valve closes. Check valves are critical for pumping systems. When the valve is closed, it keeps the fluid that was just pumped out from returning, preventing flooding the well that was just pumped out. Also, check valves prevent pumps from backspinning, a potentially costly and disastrous event. Check valves keep pipelines full. When the pump starts up, it can be a problem pumping at full capacity into an empty pipe. Surge events can occur, air valves can slam, and so on. Like so many valves, there's often more than one that'll work. We have to consider what is being pumped through the valve. Is it dirty water, clean water, air, abrasives, slurries? Are there application conditions that could cause the valve to slam? The amount of leakage allowed will affect which type of seat is required, and of course, which valve have those seats. Purchase price isn't the only consideration, but also if energy efficiency. And of course, how long will they last in the application? So a couple of things to consider. Well, one thing to consider is what's the media. If it's dirty, you know, we all, you know, deal in dirty media. What type of valves would be good? Well, two of them that are very popular, especially the swing check valve, is swing check valve or a rubber flapper. Both of them, the disc or the flapper moves out of the way when there's flow. And they also cause minimal disturbance in the flow. They'll move out of the way, and then of course things like, you know, lumpy or stringy things won't get caught in the valve that would prevent them from closing. On the other hand, you know, there are different valves for clean media. Generally speaking, all check valves, even the ones on the previous page, are suitable for clean media applications. However, some valves can only be used with clean media. Those all have something common. There's part of the valve in the middle of the flow stream that could cause them to foul up on dirty media. The slanting disc check valve on the left, lower left, it's the most energy efficient check valve that's out there. It's used a lot on like high service pumps. They have the least amount of flow disturbance and the head loss, but the disc is in the middle of the flow path. For the same reason you wouldn't put a butterfly valve in the middle in sewage, you wouldn't put a slanting disc check valve in sewage. Likewise, silent check valves, they don't have much application in our industry, but just showing you that for contrast, their disc moves with the pipe. They don't swing open, they move with the pipe, so flow has to go around it, and that valve will act more like a strainer than a check valve. And then there's double door valves, which are inexpensive valves. You might find those more on air blowers with light springs in them. Sometimes on water, if space is a concern, but they are specialists in slamming. Just the way they work, they'll slam pretty easily. So you have to be careful how you use them. And speaking of slamming, you know, we need to discuss it. Some systems have high slam potential and can be a big deal. When the pump stops, the fluid coasts to a stop and wants to flow backward. If the valve closes before the flow reverses, there's no slam. If flow reverses before the valve is closed, it will slam. Slamming can cause mechanical problems or might just be an annoyance. There's no simple formula to predict slamming, but experience tells us what to look for, such as high head system, systems with surge tanks, or vertical flow, because gravity will reverse flow rather quickly. So how do you reduce slamming? Well, most of the time it's using a lever and weight check valve, and the weight can be adjusted. Adjusting the weight is often the right solution. Moving the weight outward makes the valve close faster. You want to try to prevent slamming by getting the valve closed before flow reverses. However, adjusting that weight, there is a trade-off for that. If the valve closes too fast, it can hit the seat hard, which causes seat problems and even make the weight levers break. That's why air cylinders are a common option. They provide a soft landing when the valve closes. As the valve opens, air enters the cylinder. When it closes, the air compresses and is bled off slowly. That pillow of air is intended to take away the hard landing of the disc. Best comparison is to think of a door closer on a screen door that keeps mosquitoes out of your house. Without it, the door slams shut. With it, the door travels mostly closed quickly, then the door closer eases it into the jam. However, if something were to push hard on that door, the closer isn't strong enough and the door could still slam. Likewise, air cushions do not prevent slamming, but only help valves close quietly. Adjusting the weight is what prevents slamming. And if you can't get the weight adjusted sufficiently because it's just a high slam application, then we have another solution, which is the bottom buffer. It's an oil-filled cylinder that controls the last 10% of travel. The speed can be adjusted, but normally it only needs to control the valve for a couple seconds or less, just enough to take away the slam and ease the disc in the seat. When the valve opens, the pressurized reservoir pushes oil into the lower part of the buffer and extends the piston rod, ready for the next time the valve closes. And just real briefly, I want to just touch on pump control valves. They perform like a mechanical check valve, except they control the flow, unlike a check valve, which is controlled by the flow. If flow rates change too rapidly in a pumping system, undesirable surges can happen. Pump control valves control surge pressures during pump startup by opening at slowly controlled rate of speed to gradually let the fluid accelerate. They also control surge pressure during pump shutdown by closing at a slow controlled rate of speed to gradually decelerate the fluid. Pump control valves require actuators, either pneumatic, hydraulic, or electric motor operators. If equipped with stored energy, they can automatically fail closed upon power failure at a faster than normal rate to prevent excess reverse flow and pump backspin. Note that rapid flow stoppage can initiate unacceptable surge pressures. Surge relief valves may be necessary to protect the system from overpressure during power failure or other unforeseen events. And in other words, even after you've thought of everything and you've got everything planned for surges, some unplanned event can start a surge. That's why every system that is capable of generating an unacceptable surge pressure should have one surge relief valve. The way they work is they have a disc that holds the valve closed with an adjustable spring. When the pressure in the line exceeds normal pressure by 10 to 15%, the valve opens and dumps pressure, so to speak, back to the wet well usually. Usually only one surge relief valve is needed to protect the pipeline equipment, even when there are multiple pumps. And with pump control and surge protection, consult your valve manufacturer for guidance. We're interested in protecting the pipelines, not just the pump. So my whirlwind tour is nearly done. There are many types of valves, and I didn't mention all of them. Some we make and some we don't. Air release and air vac valves are essential for any piping system. Sometimes knife gates are used because they're compact in space. They're tall, but they're compact in terms of lane length. 3- and 4-way valves control direction of flow, divert flows, and so on. Control valves for pressure, temperature, flow rate, tank elevation, whatever, control valves. And sluice and slide gate valves is another type of valve you see in your applications. So my advice, consult your local representative for expert advice. They have been trained. And we'll support you and our representative for things we didn't really talk about much, but air valve selection and sizing, there's some method to the madness of where an air valve should go and what size they should be. Control valves we talked about, and selecting the right type of valve and the right size. Not everything requires just a line size valve, so we can help with that. And then the last one, since surge is potentially more critical and perhaps even more complicated, we provide a surge investigation report where you give us some information about your piping and pumping system, and we'll prepare a report to show you the worst case scenario for surge potential. And of course, what strategies you can use, whether it's valve or pump strategies you can use to mitigate that surge. So talk to your valve makers and valve reps for that. So you can ask questions, but I want to say, you know, after this, you know, talk to Jack Tyler Engineering. They're our rep. They do a great job, and you can contact them. A couple are in attendance today, and also you can go to their website at jtemg.com or check the Desuric website at desuric.com. And that's all I have to say. So if you have any questions, you know, let me know.
Thanks, John. I guess thanks, Scott and Jack Tyler as well. So does anybody have any questions for John? Or
I've got a question.
See any...
John, did you say you've got 32 years of experience?
Yeah, well, coming on 33. I started in 1988 at Desuric as an application engineer.
Wow. Hey, all right. Well, my question is, personally, what's your favorite type of valve?
Well, that's easy because as far as my favorite type of valve that for applications and does everything, it's the eccentric plug valve. I think it's the valve you can use. If there was such a thing as a universal valve, that's the closest thing there would be to it. But all honesty, the most interesting valves nowadays are the things you put on the discharge side of a pump, because there's definitely some application experience that needs to be applied to that to get it right. And I just find that kind of fun to work with.
What's the most unique application you've been a part of?
Oh, that's a good one. Well, you know, just yesterday we had somebody wanting to deal with incineration. You know, not too many wastewater plants have an incinerator, but you know, you're dealing with 1,000 degrees or higher temperatures, so suddenly that changes from using anything with rubber in it to, you know, other types of materials, and even stainless steel is no longer stainless after it's seen 1,000 degrees because it changes its metallurgical form. And so, yeah, there's definitely some like that. I guess one of the other interesting applications, and this was many years ago, but somebody asked us for a valve to be made out of one of the heavy metals. And I don't know if it was uranium or plutonium or whatever, but they asked us to make it out of one of those metals. And we didn't do it. We did a little research because we're not going to sell something like that unless we know exactly where it's going. And we found out it was going to go to one of the, I guess, what do you call it, the embargoed countries, you know, that we don't trade with. And so, yeah, we definitely ran away from that one screaming. Yeah.
There you go. Oh, man, good stuff. All right, that's all I got.
All right, well, thanks for the question. All right, guys, thanks for your time. I appreciate talking to you.
Appreciate you.
Thanks, John. Appreciate it. So, okay, if I think Ross, I think I saw you on there. If you're available, we can get you sharing your screen and kind of roll right into your presentation.
Oh, there we go. Okay, off mute now.
Excellent.
Okay, I see it.
Okay.
Great. All right. Well, we'll just turn the time straight over to you if you're ready.
Okay, thanks. I'm ready. I'll go ahead and jump in. Thanks for having me, everyone. My name is Ross Tate. I work for a company called Orej North America. I'm the Director of Business Development on the West Coast region. I'm located in Sacramento, California, and cover everywhere west of the Mississippi for Orej. So we are represented by ISI Instrument Supply Inc. in Arkansas, and I'd like to thank Chris for setting this up and allow me to jump on this and give a presentation for you guys. We are a dewatering and thickening enhancement technology, so a preconditioning system. I'll kind of set where we sit within the wastewater treatment plant is between a sludge pump and either your dewatering or thickening device, so either a belt press, gravity belt thickener, somewhere in between there. So as we make our way through the presentation, we are a new technology. No one else is really doing what we are doing in the market. So if you do have any questions, please feel free, put those into the chat and we can address those at the end. We should have a little bit of time left over. So I'll go ahead and jump in. Brief agenda here. I'll do a little bit of a history on the company. We'll start with our end product, so actually what comes out of our system. I'll show a quick video of that. It kind of makes the conversation easier as we make our way through the presentation and discuss the different topics of the SLG. Then I'll go through the SLG solution, and then at the end we also have a standalone thickening system that that's new to the US, so I will cover that briefly as well at the end. So Orej North America is a subsidiary of a company that started in France, and that was founded in 2005. The first, basically, almost 8 to 10 years was spent strictly on R&D, so researching different technologies. There's a few different technologies they were looking at. In 2008, we were granted funding. We are owned by Total and Ron, so one of the larger oil companies in Europe, and they funded us and they decided to focus on the development of the SLG technology. So in that phase 2 from 2010 to about 2013, we were focusing solely on getting all the patents around the SLG. So it is a fully patented system in Europe and in the US. So we have 6 families of patents, so numerous patents on the system. We entered the US market in 2016, and since entering the market,
hey, Ross,
we have.
I'm sorry to interrupt you there.
Yep.
Real quick. Are you actually progressing through any of your screens at the moment? I just want to make sure because we're just seeing your kind of a basic PowerPoint.
Yeah. Are you on the Orej history?
No, we're just we can see like the generic PowerPoint that has all your slides to the left.
Oh, okay.
And
okay, I was in presentation mode. Let me try again here. Is that better now? Or is it the same?
I wonder if the screen that you need to share, now that you have it in presentation mode, if you have to select that screen that's actually presenting.
That might be it. Let me go here. I'll just go my entire screen. Share. And then that might help us here. Let's see if this works. And there you go. Is that better now? We're full screen?
There we go. Yep, that should work for us. Thanks.
Perfect. No, thank you. So I'll continue here. So we did enter the US market in 2016. And then since entering the US, we have 6 full-time installations. So, and then we have 3 others that we're currently working on finalizing some phase of optimization or installation. And then we did enter the US for thickening in 2019. So 2019, we introduced the SLGF thickening in the US market. So SLG stands for solid liquid gas. That's a 3D image of our skid there on the left. You can see very compact, robust system. Footprint is very small. That was important to us to be able to fit into existing dewatering buildings. So we like to be as close to the press as possible. So we wanted to make sure we had a small footprint that could fit into almost any wastewater treatment plant. So this is the video of the end product. So this is what we call our air and sludge emulsion. So this is actually what's coming out of our system. So what you're going to see is this was sludge that has been processed through the SLG and then has just been injected with polymer. Let me know if there's any issues with the video. So he's going to pull a sample here. Again, this is just after polymer injection. And this is what comes out of the SLG. This is what would be sent to your gravity belt thickener or your belt filter press. You can see sludge separating, getting two distinct layers of sludge and water. Even the smaller particles start to move up into that sludge layer, and it continues to compact. So this effect would actually happen without polymer if we were to just take a sample after the SLG, but because it would take too long, we have to still utilize polymer before going to either belt filter press or gravity belt thickener, volute style screw press. We still have to use polymer, so we utilize polymer just after. So we're in between sludge pump. Here we go, sludge pump, SLG, polymer injection, and then to dewatering. So these are the 5 steps of the SLG. So we like to break it down into these 5 different portions of the system that have the impact on the sludge. So these are all bottom fed systems. So you see here on the left-hand side, this bottom portion is what we call our injectors. So this is going to be the interaction between the air and the sludge. So this is where the air is going to be meeting the sludge and breaking up that sludge as much as possible. What we're trying to accomplish with the air is we're trying to break up that those microcolonies as much as possible, break those down to release that bound water. This is the beginning of creating that air and sludge emulsion that you saw in the last video. So this is where it all starts, is in the injectors. We're also using velocities. So we're moving really quickly through here to produce some shearing force as well to break up that sludge. So after we go through the injectors where the air is met with the sludge, we go into our reactor. It's essentially a wide spot. We're slowing down the flow a little bit. We're allowing those air bubbles to expand and contract. So again, we just want to keep the turbulence up. Is mainly what we're looking to do within the reactor. This is where we really start to see the formation of that air and sludge emulsion. The next step is the PRV, so it's this red portion here. This is a pressure regulating valve. The system is held under a back pressure. Typically, we're going to be anywhere from 20 to 30 PSI within our system. So we are running on a little bit of a back pressure. The PRV is regulating that pressure. This is the only moving portion. It is a pneumatic valve, so this is the only moving part on the SLG. And once we come out of the PRV, we're going to actually have a slight cavitation since we're going under pressure to atmospheric pressure. We're going to have a slight cavitation, so you can think of this as your fire hose portion. So that sludge stream is going to be coming out with a lot of energy. So the 4th step, what we like to do is take advantage of that mixing energy. So we're actually going to introduce polymer at this point, right after this flange here. We would introduce polymer and we would utilize that mixing energy to get a good interaction to create a really strong, robust block. So once we make that air and sludge emulsion after polymer, we're going to go to our last step in our system, which is the deaerator. There's a picture here down below showing a deaerator at one of our installations in Florida. Essentially what that is another wide spot in the line. We want to drive off any of that excess air that doesn't get entrained within the sludge. So we're going to dry that off, and it's simply going to go into this nice pipe. It's a very simple but efficient solution for us, because we can take this pipe and then direct it anywhere it needs to go within the plant. So if there's existing HVAC, we can take it there. If it just simply can go outside the building, that's an option as well. Here, what they've done is they take that airstream and then they take it underneath their press, because it's an open air building. They don't have any real issues with odors. But if you did have issues with something like H2S after a digester, we can then, what we found is that when we hit it with the compressed air, it acts like a fairly efficient air stripper. So we're able to strip out that H2S, and then we can actually get a high concentration of H2S in this pipe. So rather than it coming out at the press and going out into the dewatering building, we can actually direct it out of the building or to existing HVAC or odor control systems. So it's a really nice benefit that we found of the deaerator. After the deaerator, then it just simply goes gravity feed onto the belt filter press. So some of the characteristics: sludge flow range anywhere from 50 to 400 gallons per minute, and that goes up in 50 gallon per minute increments, so 50, 100, 150, and so on. Our largest units to date are 400 gallon per minute units in Orlando, Florida. Operating pressure is anywhere from 15 to 45 PSI, but again, we typically are right in that 20 to 25 PSI range for dewatering. Skid size is about 5 foot by 3 foot and 8 foot tall, and that is true all the way up to the 250 gallon per minute unit. Once we get above 250, so the 300 gallon per minute to 400 gallon per minute units, they do get a bit wider and longer. So a little bit of what we're doing on a microscopic level. So composition of wastewater sludge, what you see here, the top is a bacterial cell, and then those typically within the wastewater treatment process become bacterial microcolonies, right? It's necessary. It happens throughout the wastewater process, necessary for settling, things like that, but not the most efficient when it comes to dewatering or thickening. So what we're trying to do is actually break that down. So any of that EPS, that extracellular polymeric substance, those aggregates that are binding these cells together, we're going to try to break those up, because there is trapped water within there, bound water. So we want to break that up, and we're going to free that bound water, but we're also going to have a secondary application to that, because what we can do is once we've broken that sludge up, so if you see here on the left, this is without SLG, on the right is with SLG. So we've broken down that gray space, freed up that bound water, but what we're also going to accomplish is that we're going to increase the surface area that polymer has to bind with. So now the polymer, rather than binding to the outside of the cell colony, is going to bind to the individual cells themselves, creating a very tightly formed flock, which you see here. So without SLG, again, broken up flocks here, not very consistent, whereas here we have very strongly formed flocks that are going to be able to be pressed at those higher pressures. That's what allows us to go in and actually change the pressures on your belts for the dewatering applications for belt filter presses, is because we have this nicely formed flock. You're not going to see the squeeze out that you typically would at those higher pressures. So again, the SLG sludge in the middle, a very dense flock. One thing that I like to point out here is these pores that are created, these channels. When that goes onto the belt filter press, that gravity zone, visually, this will be what you see. This is what we call our macro effect, because it's what you visually can see at the plant after the process. Instead of the water carrying over on top of the sludge, what you'll see is actually that the water is able to drain through these channels or pores, making it more efficient within that gravity zone. So you're actually sending less water into the pressing zones, but then being able to press at those higher pressures. Those two advantages combined are what gets us to our effect of increasing your overall performance of your dewatering or thickening. So this is a video from one of our first installations. This is going to be on a press. We had one SLG on one of their belt filter presses at this time. We now have 2 SLGs there operating. This is going to be on one of their presses without the SLG. And what you want to notice is when we start to see rows form. So again, pretty typical, very watery material coming in. We're going to be about halfway down, and then he's going to back up slightly and come back to the press. We're going to see rows start to form. We're about 4 to 5 chicanes from the end going into the pressing zone before we start to see rows. And really, even the rows that are formed aren't very defined at this point. This is going to be with the SLG. So again, just notice when rows start to form, you can see a distinct difference in the characteristics of the sludge. And then almost immediately, we're starting to see rows form. The amount of water draining off in this area is much higher than on the other press, and then going into the pressing zones. I will mention that we were using about 20% less polymer on this application, and we're at a flow rate of 10 gallons per minute higher than what the client was running at. So we were able to hit on all 3 of those. We increased their cake solids by 3 points. So it took them up 3 points, decreased their polymer by 20%, and then we're able to increase their flow rate by 10 gallons per minute. So very good installation for us for our first in the US. So the video that you just saw was Allentown. This is an anaerobically digested sludge. Again, we took them from 15.5, sorry, that is not, yes, 15.3, 17.5. This is the current numbers that we're working on for our second installation, actually. And then the polymer was the big driver there, 60 pounds per dry ton. We're able to take them down to 48.3 pounds per dry ton. Another one I'll mention is going to be GCUA. So again, another anaerobically digested sludge, belt filter press install. We were able to take them, even though they started at higher cake solids at 20%, we were able to take them up to 23, which equated to about a 2-year ROI for them. The last one that I'll mention, because it is a unique application for us, is Two Rivers. This is a municipality in New Jersey. Initially, this was driven based off of dry solids. So actually a 2.5% cake solid increase was what we originally went in with the contract. But as we started to work with the client, they identified throughput to be a larger issue. So we started to focus on throughput more than the dry solids. And we were able to actually double their flow. So this equated to them actually being able to eliminate an entire shift of dewatering. So they were running for 24 hours, 7 days a week. So they were able to take that down and eliminate an 8-hour shift by increasing their throughput. They're doubling it. And then they were also able to maintain a 1.3% increase in cake solids. So again, different types of applications, polymer driven throughput, as well as dry solids. So we do have 3 other installs currently in some form of execution. The first being in Trinity River, Texas, so Trinity River Authority, Fort Worth. And then we have Hamilton, New Jersey, and Orlando. I mentioned Orlando earlier. Those are our largest units. Those are the 400 gallon per minute units. So that's the SLG portion for dewatering and thickening enhancement. I'll talk a little bit more about the thickening portion. So we do have our own standalone thickening system called the FlowStep that we'll see a little bit more of here. I'll start with a video. This is a non-traditional rotary drum. So the reason I say non-traditional is that the flow does not flow through the middle of the drum. It actually flows on the outside of the drum. So what you'll see in this video is actually there's going to be sludge that goes through the SLG, and then is collected in a flock tank, and then rolling over the top of a wedge wire screen, essentially drum, and water is going to be flowing through the middle, and then the sludge will be knifed off on the other end, scraped off on the other side. So what you'll see here are some of the demonstrations that we've done in the US. So this is a waste activated sludge. So all secondary. This is the flock tank. So this is after the SLG. Let's show the filtrate. So that flow is going over the top of that drum and then being knifed off on the other side. That is a pressure plate on top where we can increase the pressure. This was the first time we processed anaerobically digested on the thickening system. So again, not your traditional rotary drum that you see in municipal. Most municipal applications, a little bit different of a system. It has been more used in the industrial, mainly in agriculture, but we found that because we get that float, that separation, that air and sludge emulsion, actually really pairs well with the flow step technology, and we get really good results within this system, and a very compact, again, robust kind of system, similar to the SLG. So all of these systems do utilize the SLG. So what you see here on the right is actually our skid mounted units. This is going to be very similar to the first one that we will have in the US. So our first install in the US, we've been spec'd into a project in Wisconsin, and that'll be happening at the end of this year. So it's going through the bidding process now. But it'll be very similar to the skid mounted unit here that you see on the right. Capacities are currently, we have 100 and 200 gallon per minute units, and we're developing the 300 and 400 gallon per minute now currently in France. Footprint for these are approximately 8 feet by 20 feet, and that's the skid that you see here on the right, and that's good up to 200 gallons per minute. The 300 and 400 gallon per minute units, the only thing that's going to change is that they're going to get a bit wider. So probably anywhere between 10 to 12 feet, because the rotary drum gets a little bit wider at that point. So we do have 3 different configurations available. So we have a fixed installation or skidded. So this could come without the skid as well. You have a fully mobile, so containerized trailer that can be pulled with your standard F250. And then we have a containerized system that comes in a Connex container, and we'll see a picture of that shortly. And that's going to be if you have a client or anybody who is looking at not wanting to put in a new building for thickening, they can utilize the container as a self-contained system. So this is a picture of the flow step system, again, fully enclosed. So all of our systems come fully enclosed, all of our flow steps. We use essentially a 1/2 and 1 horsepower, depending on the size, but for the 100 and 200 gallon per minute units, it's a 1/2 horsepower motor, 2 bearings on each side, so maintenance is very low. The wedge wire screen comes anywhere from 500 to 1,000 microns, and we can do some testing to identify which size screen is going to be a best fit for your applications. And then we also utilize CPEX or niche sludge pumps on this system, and we can provide a fully enclosed thickening system, so everything that you need from sludge pumps, polymer, air compressor, or we can just provide the SLG and the flow step as well. So we have a full range of products that we can provide with these applications. This is the inside of the drum. I like to show this picture because one thing that does set us apart from others is that we don't utilize very much wash water at all. So this spray bar that you see here is on a solenoid valve. So we don't have continuous wash water. We just wash when needed. So we can set that valve to go off in a certain increments. That way we're not continuously washing. If we were, we still are very low wash water. We can set it to run continuously, but typically we do not have that running all the time. So this is our demo unit that we currently have in the US that we've utilized to run the demos. We were able to get in 4, we got the system in late in 2019. And so we were able to get 4 done over the winter and then into March of 2020. And this is fully containerized. So this includes everything you need. Again, we have both feed and discharge pumps and a polymer system included in this. So when we do come on site, we can utilize the client's polymer and our own polymer system, or we can utilize the client's polymer system. Either one works for us, but very easy to hook up. We have 3 connections here. You have your feed, your filtrate, and then your discharge line coming off. Again, very easy. This is ready to go. This unit is actually located currently in Covington, Georgia. That's where our US headquarters is, and is ready to go. So this demonstration unit has been used to run waste activated and primary blends, as well as anaerobically digested sludges so far. It can handle up to 100 gallons per minute. These are 4 pilot demonstrations that we've conducted so far. Again, we've run on a number of different types of sludges and a number of different sizes of plants. So typically what we've seen is anywhere from West Wisconsin, where they have to store sludge before going out and only have about 90 days for a land application, to Central Florida, where they're doing liquid land app and want to reduce the number of gallons that they're land applying per year to save them an overall cost for disposal. And that's all for that. Any questions?
I do see one question here, Ross. They're asking if you all help with setup and system tuning, or do you only sell the equipment?
So yeah, we do that as well. So what comes with the SLG, it is a solution package. So when you do buy an SLG, it comes with an optimization phase as well. So we come in and we will do a full evaluation after we sell the unit. We sell each of our units right now. All 6 have been sold on what we call try and buy contracts. And essentially what that is that once we sign the contract, we produce a contract that says we would guarantee a certain ROI is typically how we do it. So we say, based off of polymer savings or combination of polymer and dry solids efficiency increases, we will meet an ROI of, let's say, 5 years. Once that contract's signed, the municipalities actually do not pay us up front. So we make the investment and we build a full-size system. So if it's a 100 gallon per minute unit, we'll build a 100 gallon per minute unit and have that on site. And then we will do an optimization and a field test. So we do this optimization phase. It lasts anywhere between 3 to 6 weeks while we'll be on site, fine-tuning the belt press and changing the settings on the belt press because it is a newly formed sludge. So the sludge will react differently. We even do polymer testing as a part of that optimization phase as well. And then we prove out the concept during a field test, which, after we meet that performance, that's when the utility actually pays for the unit. If we do not meet that performance, then we actually remove the unit at our cost.
Thanks, Ross. Anybody else have any questions? Okay, and you said your local rep is Instrument and Supply?
Correct. Yes.
Chris, okay. Cool.
Yep. All right. Well, thank you, everyone.
Okay.
Appreciate it. I'll stop.
Thanks, Ross. All right, we got just a couple more presentations left. We'll take a quick 10-minute break while we get ready for the next one. And we'll catch everybody at about 10:45. We still have a few minutes there. Just checking to see if Zach, if you're tackling the link for the next presentation, or do we have something else in mind? Thanks, Zach. Just a couple minutes before we get started. Just two quick things while we're waiting. We are recording this training session. So if you have staff or know somebody that was unable to attend the meeting but still needs the training hours, we do have approval from ADEQ that we will post this recording on the district website and they can watch it for those 3 hours of credit. Yeah, so be patient with us while we get that posted. Might take a couple days, but that is an option that I think is good for people. And we're waiting for confirmation from ADH, but they seemed willing to work with us on that and to work with everybody. But and before we get started on this next one, it's going to be a YouTube video on let's see, all things water course regarding activated sludge from I hope I say that right, Blacow University. So, but does anybody have any questions or comments or anything before we start the training video? Okay, well, Zach, I think we're ready if you are.
Hey, before I get too deep, can everybody hear that?
Yes, I could.
Okay.
Yeah, it's loud and clear.
All right, good deal. All right, just checking. Here we go.
Welcome to this session. This will be on an overview of the activated sludge process in wastewater treatment. Activated sludge is the main secondary biological process that's used in virtually all wastewater treatment plants worldwide. This course is not designed to teach you how to design an activated sludge system. It's designed more to give you an overview of how the process works, some of the important parameters involved, so you'll have a familiarity with it as you move forward. My name is Russ Wright. I am the chief engineer of municipal products at West Tech Engineering out of Salt Lake City. West Tech is a company that supplies and designs the large process equipment that goes into water and wastewater treatment plants. I've been with West Tech for 31 years in a variety of positions. And education-wise, I have my master's degree in civil engineering from the University of Utah, as well as several additional classes in wastewater treatment, as well as a master's in business administration. And so with that, let's proceed. We're going to talk today about, first of all, where the activated sludge process fits in a typical wastewater treatment plant flow sheet. We will then go over some important wastewater treatment parameters or criteria that deal with the performance of the system. We'll do some very brief biochemistry, and then we'll get into what a typical activated sludge system looks like, how it's configured. We will move on to talk about some important parameters that are used to operate an activated sludge system. And then finally, we'll go through some different types of systems in actual treatment plants. So typical wastewater treatment plant flow sheet looks something like this. There are many variations, but this is a very typical flow sheet. We start out with screening. This is designed to remove rags, paper, plastic products from the sewage coming into the plant. I even had an operator tell me a mattress came floating down the sewer one day. We want to screen this kind of stuff out before we get into the rest of the plant. And so there's always some type of a screen at the head of the plant. Following the screening is grit removal. Most sanitary sewers are made from concrete pipe. And as concrete wears, you get sand particles, fine grit that moves down the pipe and into the treatment plant. That grit is a problem. If you run grit through a pump, you'll wear the pump out very quickly. There are a lot of pumps in a treatment plant. That grit can also settle at places in the plant where you don't want it to settle and cause problems. So we take the grit out up front with some simple tanks and mechanisms that remove the grit. Following that is what we call primary treatment or a primary clarifier. And not all treatment plants have primary clarifiers, but any treatment plant bigger than about 5 million gallons a day typically has primary clarifiers. All that is a large basin that the liquid flows into, and any solid material in that waste stream will settle to the bottom of the tank where it can be collected and removed. And the clear, relatively clear liquid then flows on into the rest of the plant. That removes about 50% of the contaminants in typical sewage. And it's obviously very inexpensive. All you need is a big tank. Doesn't take a lot of power or energy. And so it's an important part of just about every treatment process. But what do we do with the rest? The part that won't settle, the part that's dissolved in the wastewater or is very, very fine particulate. That's where the biological secondary process comes in, and activated sludge is the main process that's used throughout the world to accomplish this. I will explain more exactly what's involved in that system, but you can see in the diagram where that activated sludge system is located. Consists of a large aerated basin and a clarifier and a recycle stream. Following that, the liquid has been cleaned quite well, and all that's left is disinfection, where we kill whatever germs are left using chlorine or ultraviolet light. Many treatment plants are going to the UV light disinfection now because chlorine is hazardous and difficult to work with. And the UV disinfection, sort of like giant high-strength tanning beds, you run the water through there and it actually will kill the germs that are left in the wastewater. On the lower part of the flow sheet, you can also see that we have to handle the solids that settle. The solids go into a thickening stage and then into a digestion stage where the goal is to reduce the volume of those solids. And then it's dewatered and it can be composted to create fertilizer. It can be directly applied on agricultural land, non-food crops. There are a lot of ways that plants deal with the solids that come off of the treatment process. A couple of important treatment parameters that we want to talk about. The first one we call BOD. That stands for biochemical oxygen demand. This is a measurement of the amount of oxygen it takes for microorganisms to break down the organic material in sewage. The microorganisms in the natural environment will do that. They will feed on a dead animal or any waste or something like that, organic matter in the environment. Bacteria break those down. And these bacteria need oxygen to live. And so if you put some waste material into a stream, for example, and the microorganisms begin to feed on that, and they use oxygen as they do so, they respire like we do, they will grow and multiply. And if there's enough waste there, they will grow and multiply to the point where they suck all of the oxygen out of the water. That's bad. Now you have a dead stream or a dead lake. It turns black, everything in it dies. Not good. That's why this is an important parameter to measure. The actual test we use is called a BOD5 test. And the way the BOD5 test is performed is we take a bottle with water in it that has been aerated, and we measure the oxygen concentration in that water. We add our wastewater sample and a seed of microorganisms that will break down that waste. We seal it tightly, and we put it in a cabinet at 20 degrees centigrade for 5 days. We pull it out, we measure the dissolved oxygen concentration, we know how much oxygen was used up, and that becomes then a measure of the biodegradable organic material that was in that wastewater that we put in the bottle, okay? Typical influent BOD, that is the BOD that's measured on the influent to a treatment plant, is typically around 200 milligrams per liter, anywhere between 100 to 350, depending on the type of community, whether they're industries contributing or not. That's a very typical kind of a number, okay? The U.S. National Minimum Effluent Standard on the far end of the treatment plant says that a treatment plant cannot put water into a receiving body that is more than 30 milligrams per liter of BOD on a 30-day average, 45 for a 7-day average. Now that's the U.S. national minimum, part of the Clean Water Act of 1972. But there are many state and local standards that are considerably tighter than that. And so the activated sludge process is helpful because from that process, typically we can get BOD down typically in the single digits in milligrams per liter or parts per million. So it's a very effective process, and it does a good job. Let's move on to TSS, or total suspended solids. This is a measure of the particulate matter in the wastewater. What we do is we run the wastewater sample through a 0.45 micron filter in a standard procedure, and whatever stays on the filter paper is considered suspended solids. Obviously there's some very refined solids that do go through, but we consider those dissolved because they're so small that essentially they are. You dry the solids on that filter paper, weigh it, now you have the suspended solids concentration for that wastewater. And again, the typical influent coming into a sewer treatment plant in the United States is somewhere around 200 milligrams per liter. There's a range there, again, depending on the type of community and the industries and so on that are in the community. Again, the U.S. national minimum standard is 30 milligrams per liter of suspended solids going out of the treatment plant in a 30-day average, or 7 days, 45 milligram per liter. And again, much tighter in certain areas of the country, depending on the water body that it's going into. Typical TSS coming out of a treatment plant that's using an activated sludge process is in the single digits. So again, very effective in removing the particulate matter from the waste stream. Okay, let's look at, very briefly, some biochemistry. And this is not very technical, but basically we want to talk about what goes on and what the microorganisms do as they remove this BOD, or this organic matter, from the wastewater. When there is oxygen present, the microorganisms convert this organic material to carbon dioxide, ammonia, and new microorganisms. Obviously, they're reproducing and growing. Those substances are fairly harmless. Now, ammonia has some problems, and we'll talk about ammonia later. But this is the basic process that goes on. Now, if you try to write a chemical equation, this is not a balanced chemical equation because there's all kinds of different organic chemicals that you'd have to include in that. But basically, on the left side of the equation, we have COHN, meaning some type of organic chemicals, combined with oxygen in the presence of microorganisms. You get from that CO2, ammonia, and that's an approximate chemical formula for bacteria, new microorganisms. Now, I said this was the equation, the biochemical equation for removing BOD. Where's the BOD in this equation? Well, remember, BOD stands for biochemical oxygen demand, meaning it's the oxygen that's absorbed in the biodegradation of this organic matter. So in a sense, it represents the organic matter. It's a surrogate for actually trying to measure all of these different organic chemicals and their concentrations. You could also say, well, it is the oxygen that's being consumed by that. In the wastewater industry, they're kind of used simultaneously. And we often talk about removing BOD as if BOD were a substance. It's really a surrogate for all of this organic matter. The urine, the feces, the food products that are ground up in your disposal, and everything else that ends up in the sewer that's organic in nature and can be degraded by these microorganisms. So when we talk about removing BOD or how much BOD is in the wastewater, a lot of times the professionals are really meaning how much organic material is there that we need to get rid of, okay? All right, let's talk about a typical activated sludge system and what that looks like. This is just a very simple diagram. Basically, we have a large tank we call an aeration basin, and we have a clarifier, which is a settling basin. Our flow comes in to the aeration basin, fills that up. Now, in an aeration basin, we have, logically, some kind of aeration system. We either have diffusers on the floor that bubble air up through the liquid, or we have some kind of mechanical device that stirs and churns up the liquid and gets oxygen and air to dissolve in that water so that there's plenty of oxygen for the microorganisms to do their job. From that point, the liquid goes into the settling basin or clarifier, and the microorganisms actually settle to the floor of the clarifier. And the liquid that comes out the top is, like I said, typically single digit in BOD and suspended solids. And so the clear liquid flows out the top, but we take the solids that settle in the bottom of that clarifier and we recycle them. We call it return activated sludge into the aeration basin. So the sludge that settles in the clarifier is recycled into the aeration basin and activated to work on the contaminants that come into the system. So when we keep doing that until we have maybe 30 times the amount of microorganisms in the system than we had in the waste stream that was coming into the plant in the first place. So we can degrade this organic matter 30 times faster than if you were to put it in a stream. That's the whole goal, is to use the natural biological forces in nature to clean the water, but do it quickly and in a confined space. And that's the reason we have to add the air to the tank, is because with that many microorganisms, they're using a lot of oxygen, and we have to add extra oxygen rather than just what is going to dissolve in the water through the atmosphere. And so we have to provide that extra aeration. Now, this is not just a mass balance of solids in and solids out, because these microorganisms are growing and multiplying. And so there's a significant amount of solids that are actually generated by this process. It's new microorganisms that are growing. They're absorbing this organic matter and growing new cells. So you have to remove some from the system. That's what we call WAS, or waste activated sludge, the solids that are wasted from the system and disposed of. Let's talk about some operating parameters in activated sludge. These are not terribly difficult systems to operate, but there's some important things that need to be watched so that the system performs properly. The first one we'll talk about is the mixed liquor suspended solids concentration. Mixed liquor is called that because it's a mixture of the raw feed coming in and the returned sludge from the clarifier. So it's mixed to form this liquor, and it has a concentration of solids. Typically, in an activated sludge system, that's anywhere from 2,000 to 4,000 milligrams per liter of solids, most of which is actually the bacteria that are doing the work to break down the organic material in the waste. If you can run at a higher mixed liquor concentration, you don't need as big a volume because you can pack them in tighter and treat in a smaller footprint. But the maximum concentration you can practically get by with is limited by a couple of things. Air requirements, that is, if you pack them in too tight, you cannot physically get enough air dissolved in the water to keep all the bugs alive and active. The second problem is in your settling basin. If you have too high a concentration of solids, it will not settle as rapidly. And you'll need immense clarifiers to try and settle a very, very thick or very, very high concentrated solids. And so that limits the concentration that you can build this aeration basin concentration up to. And like I said, typically it's between 2,000 and 4,000 milligrams per liter. Dissolved oxygen concentration. This is obviously critical. As I've talked about, these microorganisms respire and they need the oxygen dissolved in the water to work correctly. It has to be sufficient to really degrade all the organic matter, or BOD, in the waste. Usually we set it at about 2 milligrams per liter. So we have an oxygen sensor in the aeration basin at all times, and we keep the level in that basin at about 2 milligrams per liter. So there's a little bit excess oxygen that's always there for the microorganisms to do their work. If you set it too high, there's a couple problems. First of all, it wastes energy. You're spending a lot of energy churning up the liquid or blowing air into the liquid, and that's a very expensive part of the waste treatment process, is this aeration. And so you don't want to set it too high. On the other hand, and also if it's too high, you create an environment that favors a certain type of bacteria that we call filamentous bacteria. Most of the bacteria that do this BOD removal for us are small, round, or oval-shaped bacteria, like you see in your lab microscope if you've taken any biology classes or anything like that. But there are other types of bacteria that are filamentous. They look like tree branches or feathers with long filaments. They like the environment with a lot of oxygen. And so we'll grow more of those if we have too much oxygen in the system, and they don't settle well in the clarifier. It's like dropping a feather. It doesn't drop nearly as fast as a rock. Very similar analogy. So we don't want the oxygen too high in the system. On the other hand, we don't want it too low either. If it's too low, you're not going to get the BOD removal you need, because the bugs, we call them bugs, the microorganisms, can't remove the organic material. And if it gets really low, it will go anaerobic, which to most of us means it's smelly. Okay, it's gone rotten and it stinks. You're going to get hydrogen sulfide and other gases that the neighbors around the treatment plant are not going to appreciate. Okay. Hydraulic retention time is the time the liquid stays in the system. pretty straightforward, typically 4 hours to 24 hours, depending on the process and how much contaminants we need to remove. Simple equation, the hydraulic retention time is the volume of the reactor or the aeration basin divided by the flow rate, Q. And that gives us an average time that the liquid is in the system. That's a simple parameter, but it's important. If you have, say you have a storm and your city is one of those unlucky cities that has combined sewers, that means the storm sewers and the sanitary sewers go to the same pipes. You have a big storm, you suddenly get a great increase of flow through your treatment plant. And if that hydraulic retention time is not long enough, it's not long enough for the bugs to eat the organic material that's in the water. So you do have to watch that and size the basin so that you have enough retention time for the microorganisms to do their job. Even more important in this type of a system, though, is the solids retention time. How long do these microorganisms stay in the system? Now, since we're recycling them back from the clarifier over and over again, the solids retention time is much longer than the liquid or the hydraulic retention time. We also call this the mean cell residence time because these are bacterial cells that we're talking about. Typically, it's 2 to 8 days for simple BOD removal. If we get into nutrient removal processes, which is another class that we'll talk about, it's even longer. But for typical BOD removal, most wastewater plants, this solids retention time is between 2 and 8 days. And it needs to be long enough that we allow the organisms to reproduce and grow. If our SRT is shorter than the reproductive cycle of the microorganisms, they'll be out of the system before they reproduce, and we can't get the concentration we need to do the job. So this is a very important parameter that we have to design for. This is the equation. It's a little complicated, but it looks a little complicated, but it really isn't. The SRT is basically just the volume of the reactor times the concentration of solids in the reactor, which gives you a mass of solids, divided by two things. We have the waste sludge that's leaving the system. That's represented by the Q sub W times the X sub W, X being the concentration in those wasted solids, Q being the flow rate of the wasted solids, and the solids leaving the system in the effluent of the clarifier, which we hope is very small. But to be technically correct, we have to include it in the equation. In practical circumstances, a lot of plants don't even use the effluent solids in this equation when they calculate their SRT because it's pretty negligible compared to 2,000 milligrams per liter in the aeration basin, and you may be getting 5 out of the clarifier. Not 5,000, 5. And so all we're doing is we're saying, here's the total mass of solids, and here's the amount that's going out. So that's what this equation represents. Finally, another parameter that's important is what we call the food to mass ratio. This is a ratio of the BOD coming into the plant per day to the mass of microorganisms that's there. You can liken this to the amount of food that you eat every day divided by your weight. Somebody who weighs 200 pounds can eat more in the way of calories and food than somebody who weighs 100 pounds. Same is true in microorganisms. This is measured in pounds of BOD per day divided by pounds of biomass or solids in the reactor. Normal range is 0.2 to 0.5. You or I couldn't eat 20 to 50% of our body weight in food every day, but microorganisms do. They have much higher metabolisms than you or I do, which is lucky because otherwise we'd be drowning in waste in the world, right? But if we can't go too far out of this range or we have problems. If it's too high, then the microorganisms simply can't eat it all. They can't handle it all, and you won't remove all of it from the waste stream. And you also get what we call viscous bulking, which basically I liken to fat bugs. These microorganisms have eaten too much, and it actually changes their specific gravity. That's not really fat. They don't get fat, but it's analogous to that, and they don't settle well in the clarifier. And they'll even float sometimes, and that doesn't work because you take the clear liquid off the top of the clarifier. But if it's too low, Again, you have problems with these filamentous organisms that are more efficient at getting what little food is there, and so they tend to predominate, and again, you have poor settling in the clarifier. So you have to keep that food to mass ratio in a fairly stable range for this system to work properly. Let's look at different types of activated sludge systems in a practical standpoint, actually in plant designs. The most common, for particularly in larger plants, is a diffused aeration system where we bubble air from the floor up through the wastewater. Here's a picture of a tank that has a bunch of diffusers on the floor of the tank. It looks something like this, and there are many varieties of diffusers. They can be designed for coarse bubbles, which do a better job of mixing but not so great a job of oxygen transfer, or fine bubbles, which are do a much better job of dissolving oxygen into the liquid but don't mix quite as well. And there are many, many variations in shapes and sizes and designs that people have come up with, but basically they all just bubble air into the water. And you need a blower or a compressor to push that air through the pipes and through these diffusers into the wastewater. The other type that's commonly used is some type of mechanical surface aeration. Here you can see we have a vertical turbine aerator, and it's splashing and churning the water. As it does that, the air gets entrained in the water and it dissolves oxygen into the water. This is what one of those looks like when it's not submerged. Water level's about there. It's only at the surface, but it acts to mix and aerate the liquid. This is an example of a plant that's using those mechanical surface aerators. You can see it's just a big rectangular basin with 6 cells, each one with one of those mechanical aerators in the center. This is actually not terribly common. Typically in rectangular tanks, we use the diffused air systems, and the mechanical aerators are saved for a type of design we call an oxidation ditch that I'll show to you in just a minute. This is a horizontal brush aerator. This device spins around its axis, horizontal axis there, and it's partially submerged. So those paddles go through the water and basically do the same thing as the other one. They simply churn the surface up so they get a lot of foam and churning and air entrained in the liquid. And it also imparts a velocity to the liquid so that you can mix a tank. This is the oxidation ditch I was talking about. This is the most common application or the common type of tank that's used with mechanical aerators. In this system, the tank looks sort of like a racetrack. It's an oval. And the influent comes in one end, and you have either a vertical turbine aerator at the center of the circle at one end that will spin, or you put one of those horizontal brush aerators on one side, and it acts to move the liquid around this racetrack and aerate it at the same time. And of course, we have to then go to the clarifier and return our activated sludge back to the basin. This is a photo of some oxidation ditches. I chose this photo because it actually has both types of mechanical aerators. On the right, we have 4 vertical turbine aerators. In the ditches on the left, we have 6 horizontal brush aerators. Obviously, 2 different phases of development of a plant and expansion that occurred. Quick summary. Activated sludge is the most common secondary biological process used in wastewater treatment. It includes an aerated tank and a clarifier following, and the sludge that settles in the clarifier is recycled back into the aeration basin to increase the amount of microorganisms to treat the wastewater. We talked about some treatment parameters that measure the effectiveness of the treatment process. Those were BOD, biochemical oxygen demand. You remember that's the amount of oxygen that's used up in breaking down that organic material. And then TSS, which is just a measure of the particulate solids in the wastewater. We talked about some important operating parameters. Mixed liquor suspended solids, that's just a measurement of the concentration of solids in the aeration basin. The dissolved oxygen concentration is critical to good growth of the microorganisms. The hydraulic retention time is important to give the microorganisms time to break down the waste. The solids retention time is important to make sure we have enough microorganisms in the system. And finally, the food to mass ratio is just a measure of how many microorganisms we have versus their food supply. And we have to keep those in the right balance. I mentioned a couple types of activated sludge systems. We have diffused air systems, which can be coarse bubble or fine bubble, and can accommodate basically any tank shape you want, because you can simply put the diffusers on the floor. You can have a very odd shaped tank sitting in a corner of a wastewater treatment plant. If you want to expand your plant, you can put diffused air in the bottom of that and use it as an aeration basin. The other kind is mechanical surface aeration, which is less expensive typically in power cost, but it's most often used in an oxidation ditch type of a design. With that, I thank you and have a good day.
Thanks, Zach, for playing that. I'd love to ask him some questions, Mr. Wright, but I know we have some really good process people on the Zoom call today. If anybody has any process-related questions to wastewater treatment, I'm sure we could entertain those. Okay. We have one more presentation. Chris Inlow with Instrument and Supply. Let's take just a quick 5-minute break. We'll get Chris ready, and we can probably press on a little bit early if that's okay. Chris, is that okay with you, or do you need a few extra minutes? Or
I'm ready when you guys are.
Okay, well, I'm good. If you want to share your screen and go ahead and start. So.
Okay. All right. Hopefully everybody can see that.
Yes, I can. Thanks.
All right. Very good. We've been fielding several calls for clay valve, pressure reducing valve, startup and troubleshooting questions. And so I thought that we would play a couple of videos from the clay valve website. Before we do that, I'd just like to introduce those videos and talk a little bit about link to valve. So Instrument and Supply has been a clay valve representative since 1982. We're going on 40 years here in another year or so. The investment that clay valve has put into maintenance and operator support has been tremendous over the last few years with the online resources, and Link to Valve is one of those resources. I'll just click this link here. This should take us to a website, clay valve. You can see clayvalve.com. The link is up here. If you just hover over these tabs at the top, it describes a lot of the different types of valves that they produce, not only for waterworks, but some other industries. We are, the municipal market falls under the waterworks category. So about 90% of the clay valves that you see are going to fall under this first column. And information that you need about those types of valves can be found under those links. You can just click on the links and you'll see there's lots of different types of valves and lots of resources available. You can get the engineering data sheets. You can get the operation, installation, operation, and maintenance manuals right at your fingertips there. It's pretty handy. Also, you can get a quick startup guide. So if you need just a quick reference, that information is available at your fingertips. Also, sorry, let's get back to this page. It describes some of the controls and—
Hey, Chris.
Yes.
Sorry, if it's something you really, really want us to see, we can't see it. We're just seeing your PowerPoint presentation there. But
oh, apologize. Yep, sorry guys. It's let's see. Is that better?
there we go.
Should be showing the website here. Okay, I apologize. Again, here's the links across the top. Here's references to the various types of valves that fall under the waterworks industry. You know, for today's purposes, we're talking about pressure reducing valves. The 9001 is right here front and center. Here's the engineering data sheets, specifications. Here's the O&M manuals that we were talking about, or a quick startup guide. Again, if you just click that, it'll download the manual right away, and it describes all the features of the valve, of a basic valve. So we won't dwell too long on those. What I wanted to talk to you about was the Link to Valve program. It's a personalized website for your utility or your company, where you have multiple valves installed in the field, and sometimes are too busy to keep up with the day-to-day maintenance or inspection of those valves. This website will help you catalog those valves. It'll help you, it'll send you email notifications for recommended service periods. So if it's time to clean a strainer, or if it's time to do some maintenance on a particular valve, it'll just send you a polite little email that says, hey, you might want to go check some of the service parameters on this valve. It's pretty handy. It also is a pretty good way to just keep a good list of the valves you have installed in the field, and it provides some good training resources. I'll just log into Link to Valve here and just show you some of the an example of some of the information that's at your fingertips. As you can see, there's a map, so it shows some of the various valves in the system. I'll just dive into a typical location to show you the kind of information that you can use for maintenance and training purposes. You can see there's a map here of the exact location of the valve. There's some photos that I've uploaded to show you what the installation looks like. So if you need to go do maintenance, you can prepare, or you can prepare your field personnel for, you know, let's say you have somebody new who hasn't been to the site yet, maybe doesn't know where it is or what to expect. This is a really good tool for that. And it's totally free. So, and it's not restricted to clay valve valves. Clay valve would like you to use it and you know, get the benefit out of the training and service capabilities that it would offer to you. It's available. I'm using it on my desktop here with Windows, but you can also get it on your mobile phone. So again, if you're having trouble locating a valve, maybe you have somebody new who hasn't spent a lot of time in the field around the locations. You know, this is just again, it's a good tool that'll help you kind of streamline some of that field service for your valves in the field. So that's the Link to Valves program, and again, that's direct through Clay Valve. You don't have to go through Instrument and Supply to get that set up if you want to start using that resource. Another thing that they have is Clay Valve University. This is some online training seminars that they do. You can sign directly up for these. There is a charge. It's a 2-hour session, and I believe it's a $60 fee per session, but there's no limit on the number of people that can watch the session. It just is a small charge to cover the cost of the presenter's time and the resources required to put on the seminars. So anyway, as you can see, there's quite a few things there that might be of interest to you. And you can certainly contact Instrument and Supply if you have any questions about that or want to get involved with any of those. We'd be happy to facilitate those. And then just kind of the last thing here is under resources. It's kind of the same information that I discussed on the in the market segment, but you can see here there's AutoCAD drawings and a cavitation guide that might be of use to you if you're having cavitation issues. The resources are here to help you diagnose and troubleshoot some of those issues that you might experience in the field. So with that, I'm going to launch back into this other screen. Actually, I'm going to release the share, and I'll ask Zach to start that first video. It's the pressure reducing valve startup video. It's about 13 minutes long or so. And then when we finish that one, I'll field any questions that you might have if I can. And then if there's no questions, we'll launch into this troubleshooting video, which is again about 10 to 12 minutes long or so. So I'll release the share, and Zach, if you would start the startup video.
All right, taking it over. Let's see how this goes.
Thank you, sir.
Right. 1 second. Got it. So I am going to sound. Oh, that's fine. All right, everybody see that?
Yes, I can.
Okay. Can you hear it?
Yeah.
All right, here we go. Let it fly.
Hello, my name is George Aguilar. I'm the training manager here at Clayval headquarters in Costa Mesa, California. In today's video, we're going to be discussing and providing you with a live demonstration on the startup of our 90 series pressure reducing valves. Let's get started. So in this video here, we're going to talk about a startup on our pressure reducing valve or our 90 series. A startup or just bringing your valve online, the procedures to go through. So this here is our standard 90-01. Again, one of the first things that we want to do is make sure that we have our IOM. All right, we have our installation, operation, maintenance guide. It gives you the operation and startup procedure on the left-hand side. Again, this also gives you a troubleshooting chart on the right. On the back side, you have your schematic, your exploded view of your main valve, your components on the right, and again, most importantly, you have your CRD adjustment range chart. This adjustment range chart is based on your spring ranges, your spring colors, and the PSI change per turn on each of those springs. The CRD that we currently have on this valve here is 30 to 300, which is a green spring. So the PSI per turn rate is 27. These CRDs, if it's a newly purchased valve or newly installed valve, these are preset at the factory at 60 PSI. The one that we currently have here is going to be set at around 40. So it's important to know where you're at. You can also get these preset at the factory. If we're following along on the operation and the IOM, one of the first items that we talk about is our speed controls, making sure that our speed controls are completely backed out. So we'll go counterclockwise, make sure that that speed control is backed all the way out. These speed controls are fine-tuning instruments here. These are to be used and to be adjusted when your valve's actually running in your system, making those changes on the fly, seeing what if your system is, if the valve is moving, if it's chattering, that's where those speed controls will come into play. You won't see any of that on the initial startup. So we want to start with those all the way out. This is our opening speed control. Again, if we have a closing speed control, it may be installed here, maybe on the back side, but you want to make sure you take both of those and back those all the way out. So first we're going to need some pressure. Before we bring this online, just to make note, our downstream gate valve is closed. All right, we do have ball valves on this valve. We have our number 1, which is our inlet. We have number 2, which is our cover. And then we have our number 3 ball valve here. This is our outlet. What I like to do is I like to start with this outlet ball valve closed. And again, our downstream gate valve's closed as well. So let's get some pressure going here. And you can see our pressure starting to build up. There's our 60. Now the pressure that you see right here on this downstream gauge, this is within our pilot system. All right, this gauge right here, this is our actual system pressure. So you'll see that this valve stayed closed on that initial startup. And again, that's because we're keeping this number 3 ball valve closed. So we have 0 pressure in our system. This pressure is within our pilot system, and we have 60 PSI coming from our system side. So the first thing that you want to do is you want to make sure that we bleed any air at your high points. So our high points will be right here. We have an X101 installed on our valve. Our X101s have a little bleeder on the top. We'll loosen that up slightly till we get that little run of water, get that air out. You also want to bleed any air at your high points of your tubing. So in this case, I loosen that up right there, get that flow of water. And we're good. So now, again, if you're unsure of where your setting on your CRD is, all right, you can make those adjustments. I'll show you how to use our X141TA. This is our CRD tester. This is used in those cases where you cannot flow water within your system. But right now we're going to assume that we can flow. In order to set this in a flowing condition, we're going to have to open up our downstream gate valve. We have to get some flow. So number 1, what we'll do is we're going to open up our number 3. Slowly open up number 3. Again, there's 0 pressure on our outlet side right now. All right. We'll open up number 3. If we look at our flow meter here on our VC22, you see that there is no flow. So now we have to make sure we open up that downstream gate valve. We'll open that up. We'll get some flow going here. There we go, 76. It doesn't have to be a lot of flow in order to set your CRD. But most importantly, you need some type of flow downstream. If you cannot open up that gate valve, this is why it's important that you have gauges as well, because if my pressure here is not moving, if this pressure matches what my inlet pressure is, then that valve or your gate valve, you're not flowing any water. So you got to make sure you're flowing something. So now that we've got our flow, we're looking at about 120 GPM right now. The customer has requested to set this valve at 35 PSI. So what we're going to do is, again, we're going to look at that IOM that I referenced earlier. You're going to see what your PSI per turn is. Clockwise will always increase your CRD set point. Counterclockwise is going to decrease You always want to make your adjustments slow. So here we are, let's get to that 35 slowly. If you initially do not see any change in your downstream pressure, let the system react. Give some time for the valve to react to the changes that you're making. You don't want to make your adjustments quick. You don't want to make your adjustments too much, too far. Just make your adjustments slow. Allow the system time to react. We'll drop it down a little bit more. Right about there is our 35 PSI set point. Again, making sure that you have flow downstream. So let's back up a little bit. Let's show you guys the other way of setting this. So what we're gonna do is we're gonna close our downstream gate valve. And we've closed number 3. So we're right back where we started, just before we bled the air. All right, our number 3 is still closed. You can see our pressure's dropping on our system side. Now again, this is how I would set the valve, based on the fact that you can't flow any water downstream. Again, if that gate valve is closed, you would need some type of hose bib, some type of drain, anything to relieve that downstream pressure. Or I mentioned earlier, you can use our X141 CRD tester, our X141 TA. Our CRD has 3 connections. We have one inlet. There's only one inlet. This port here and this port here are both common. So what we're going to do is we're going to go 3, close number 2, close number 1. Again, by closing all those ball valves, we've isolated our pilot system. And now what we're going to do is we're going to remove this connection going into the CRD. Okay, so we've removed our connection to our CRD. Now we're going to take our CRD tester . So we got our CRD tester threaded in there. All right, we're going to close the ball valve on our CRD tester. Now what we're going to do is we're going to open up, because we still have our inlet pressure. Remember, we opened up that inlet gate valve earlier. So we still have our inlet pressure of 60 PSI. And now what we've done is we've brought that 60 PSI to the pilot itself. So what we're going to do is we're going to slightly open . We'll slightly open our ball valve on our CRD, just so we get a little bit of flow. So we get a little bit of flow here, and now when we make our adjustments to our CRD, you can see that change and that setting of that CRD. So you can see I've brought that up to about 50 there. There's our 40. Now if we want to get to our customer requested 35 PSI, we'll drop that down. There's our 35. And now our CRD is set. So let's close our number 1. And let's remove our test assembly. All right, so now we removed our X141 TA, our CRD tester. We got our tubing connection back on there. Now it's important to know that when you set your CRD by using this tester is only seeing this little bit of pressure right here. So your CRD is going to need a slight difference in adjustment when you actually bring it online. But it's good to have this. It's nice to have this on there to get your CRD setting close to the setting that you want. It also verifies that the CRD is working. So now all we need to do is actually bring that water pressure into the system. So what we'll do is we're going to open up number 1. Again, this brings water pressure onto the cover. We open up number 2. At this point, you would bleed your air out of all your high points. And then we're going to open up number 3. slowly filling that line. And now we'll slowly open our downstream gate valve and let some flow going through there. So now you'll see again our setting when we used our tester was at 35. You'll see we're just under 35, but because we have that 30 to 300 spring, all we have to do is make that slight adjustment to get to that 35. All right, so again, you will be a little bit off by using that test assembly, but it's nice because you get to see your CRD working and you're close. You're just making small adjustments once you get your system running. Now we'll do a shutdown. That concludes the video today. Thanks for stopping by and watching. For further videos or any other questions, please visit our website. Have a great day.
All right, I'll field any questions if anybody has a question about startup of a 9001. If not, Zach, you can roll right into the next troubleshooting presentation.
I want to give everybody a minute. You got it? Any questions? All right, we'll move on. Go on to the next one.
If you can type those questions into the chat bar if you'd like.
Sure. And then we can answer them after this.
Hello, my name is George Aguilar. I'm the training manager here at Clayval headquarters in Costa Mesa. In today's video, we're going to be discussing what to look for when troubleshooting our 90 series pressure reducing valves. Let's get started. So in this video here, we're going to go over some troubleshooting tips and a couple of items to look for when troubleshooting. So the first thing that you want to do is you want to visit our website or contact your local Clayval rep and make sure that you get yourself one of these IOMs. Again, these are available on our website as well, but the great thing about these IOMs is it gives you operation and startup procedures. You have maintenance tips, and you also have a chart right here of some of the things that you may want to go through when troubleshooting. You have a symptom, a probable cause, and a remedy. So it gives you a couple items to look through. On the back side of this IOM, you get an exploded view of the main valve, a schematic of the 9001, the common components that you'll find in a pressure reducing valve or a 90 series, and most importantly, you have your CRD cutaway here that has your spring chart. So it's important information that you know, or it's important that you have this information for your CRD, so that way you know your adjustment ranges depending on what spring you have. So on the chart on the far right here, you have PSI change per turn. And again, that PSI per turn is based on which color spring you have inside of your CRD. So in this one here, I have a green spring. This is going to be a 30 to 300. That's the same one that we have installed on our valve. So going through some of the symptoms or the probable causes that you may have with your 9001, we're just going to go down the list here with our IOM. If your valve has failed to open, all right, meaning that you're not getting any water downstream, your downstream system pressure is getting really low, some of the things that you want to look for, number one, you want to make sure you have sufficient pressure on your inlet. All right, hopefully you have gauges on your valve or gauges within your vault so you can verify what those pressures are. First and foremost, you want to check that. You want to go through your main valve checks. Make sure that your hydral is working properly. If your valve hasn't been serviced for a while, if you have really aggressive water if you had a main break, any of those things can allow the main valve not to work. The main valve may be stuck, it may not be able to open, and so on. For those videos on troubleshooting your main valve, please visit our website. Now, as far as the CRD, verifying that the CRD is working, if you're not getting any pressure down below into your system, the first thing that you would want to do is vary the adjustment on your CRD. Maybe someone made changes to the CRD and it could be set too low. So the first thing that you're going to want to do, again, we'll verify we have some pressure. We'll get some pressure going here in our valve. All right, you see an inlet pressure starting to rise here. So currently our system pressure is running at 60. Our CRD, or what we believe our CRD is currently set at, as 40. So again, the first thing you want to do is vary the adjustment on the CRD. So we're going to remove the black cap. The CRD, to make changes on your CRD, it's always important to know, again, that you have that spring range. It's also important to know that clockwise always increases. On any of our pilots, clockwise is always going to increase. Counterclockwise, obviously, will do the opposite and decrease. It's important to know what you are changing. So in this case, when we decrease our pressure, or when we go counterclockwise, we should be decreasing. So let's try that out. And you see our downstream pressure has dropped. We're just above 30 there. Let's bring that back up and verify that the CRD is working. It seems our CRD is working just fine. The other option, or the other item to look for, if your valve is not opening, if you've already done those other 3 checks we've just discussed, these speed controls that you find on here, these speed controls, they could be buried. Right now, this speed control looks like it's all the way out. Let's show you guys what it looks like when it's all the way in. If you open up your speed control and you see this, that speed control is buried. That needle that's inside there is absolutely buried. You want to make sure that when you're troubleshooting or when you're going through startup or anything, that these speed controls are backed out completely. We'll back that out. And we'll put that cover back on. And those are basically the deals that those are basically the items you're going to look for when trying to deal with figuring out why your valve is not opening. Now, just the opposite of that, some of the items to look for when your valve is not closing. Okay? When your valve is not closing, you want to verify, number one, that you're getting water pressure onto the cover of the valve. All right, you have a couple of restrictions here. If we follow the inlet, if we follow our tubing here from our supply pressure, if we follow this supply pressure, one of the first things that we come across is our strainers. Again, you're gonna have either the Y strainer or you'll have the inline strainer. So to verify that we have pressure right now, with the Y strainer, it's great. We have a little blow off on here. So all we have to do is just open up this blow off. And we can see that our strainer is pretty clear there. All right, if I didn't have this blow off, or if I didn't have this Y strainer, one of the options would be to close our cover connection, close our outlet, and close our inlet. And now we can open up our number one, our inlet ball valve, and you can see we got water pressure coming off there. Verifying that our inline strainer is good. We also have, right after the strainer, if you verified that the strainer is good, we'll open up all our ball valves here. You verify that the strainers are good. The next point of restriction is going to be our restriction fitting. Now this restriction fitting, all right, this restriction fitting looks like this right here. You can see that restriction fitting restriction right inside there. Our copper ones or our brass ones here on our copper and brass fittings. This is all stainless. We do have optional inserts depending on how aggressive your water is. But what can happen if you have really aggressive water, maybe some higher pressures, if you're using our standard Delrin insert, you want to make sure that you verify that that insert is actually inside there. If that insert is clogged, all right, for whatever reason, if that insert is clogged, you're not going to get any water onto the cover, the valve won't close. And just the opposite, if this restriction fitting is blown out, then you would be putting too much water on the cover and you'd be flooding it. That would allow the valve to not open. All right. For operations on the restriction fitting, you'll have to see our operational video. But again, you have to have that restriction fitting in there. You want to verify that that restriction fitting is good and clean. Also, when troubleshooting your valves, if you want to check your cover connections, make sure there's no buildup on your cover connections. If there's no water coming off the cover, or if this cover connection's clogged, you're not going to be able to get water on or get water off the cover. That can hinder the valve operation as well. Now, to verify that just the hydro works, you see that we have our ball valves. We have one on the inlet. I call this our number 1. We have one on the cover. I call this our number 2. And then we have a number 3 ball valve, which is on the outlet. The great thing about these ball valves is you can manually operate the valve to do what you want it to do. In this case right here, before you start closing any of these ball valves, you want to make sure that you check the effect in the system, all right, before you do this, because this valve may shut, this valve may open. You want to make sure that you check the effect in the system. But there's a simple shutdown sequence that you can do using these ball valves. So what I'll do is I'll shut number 3. By closing number 3, we follow our inlet. Water pressure has nowhere to go because this is closed. Water pressure backs up onto the cover, the valve closes. At that point, we can close number 2, which locks the water pressure in the cover, keeping the valve closed or keeping the valve at its current position. And then we close number 1, which eliminates our water supply. By having these ball valves, if we did find that our strainer was clogged, or if our restrictor fitting was blown out or clogged, if the CRD wasn't tracking like it was for us earlier, by isolating this pilot system, now I would be able to disconnect we can disconnect our tubing here, and you can see we have no water pressure. I can make any changes I need to the pilot system, and we're good to go. We would be able to make any changes. You know, let's say if our CRD yoke or our disc is bad, maybe we had that main break, our strainers are clogged, we would be able to make those changes. So our shutdown sequence was 3, 2, 1. Our startup sequence, we're going to open up number 1. You see our 60 PSI come in. We open up number 2. You want to make sure you always bleed the air out. So you're going to loosen up some of these fittings at your high points. If you have a position indicator or an X101, we have a bleeder on the top there. We'll loosen that up, get some of that air off the cover. And then lastly, number 3, we'll open up number 3. Number 3 is always going to be slowly. And we're back running at 40. It's important to remember as well, when you have gauges on your valve like this, All right, this gauge is connected just before this ball valve here. So when we do close it, you'll see this trap pressure. This trap pressure is just within the pilot system here. You can see our gauge. This is our actual system gauge. That's down to 0. So this valve is closed. We're just having a little bit of trap pressure here. So that will be it for our troubleshooting. That concludes the video today. Thanks for stopping by and watching. For further videos or any other questions, please visit our website. Have a great day.
Okay, that concludes the video presentations I have for today. If anybody has any questions, again, don't hesitate to shoot me an email or give me a phone call. Most of you have my contact information. If not, let's see if I can share that here. There's my contact information. Don't hesitate to give me a call or drop me an email if I can help with anything. I don't see any questions here. All right.
Anybody got any questions for Chris? Okay.
Hey, I've got one request. Some of you may be watching with multiple people in the room. If you are, could you please in the chat bar just type how many people are in the room with you? I would appreciate it. And with that, I'll turn it back over to Mayo and Zach.
Hey, thanks, Chris. Appreciate it. I can tell you've given a few of these presentations and pretty familiar with Zoom and stuff, so appreciate that. So
yeah, nice job today, guys. Appreciate you.
Yeah, really thanks to everybody. Glad we could really make something work. There will definitely be more coming down the road. To wrap things up today, we just have 2 quick things. First of all, Jack Tyler has offered a door prize. Scott Jones says he has a Jack Tyler mug that he'd like to give away, and I just plugged in a random number generator, and that number fell on Gary King. So Gary, I don't know if you can still hear us there, but I know how to get your contact information. We can put you in touch with Scott Jones and get you that mug.
Hey, I appreciate that.
Yeah. All right, well, let's jump into I know it's been a long morning. Some of you have been here for, kind of start super early. We just want to wrap up with a quick board meeting, so to speak, or a business meeting. And I'm going to share my screen, if that's okay. Make sure, can everybody see that Word document?
I can see it.
I have there. Okay, great. Well, we will go ahead and call this business meeting to order at 11:59. And I just want to say thanks and sorry it's been so long. It seems like we had 3 meetings last year, January, February, March, and then COVID hit, and we kind of played the waiting game to wait and see what happened. Governor recommendations, state regulations, and as ADH and ADQ made rulings on training hours and what was or wasn't required. Once we got that, then we really hit the ground. I think it was late in 2020 ADEQ made their final ruling. So that's when we started organizing things and getting ready for meetings in 2021. But so we will have more coming. Thanks again for everybody coming, presenters for the training hours. Yeah, it was really good. I appreciate it. As kind of was mentioned in the chat earlier and discussed, we do have approval from ADEQ. I know the total time for this meeting has been more than 3 hours, but ADEQ, they did approve 3 direct training hours for their towards wastewater licensing. and we're still waiting to hear exactly what ADH is going to approve for this. So, and you've probably all seen the rulings from ADH. They waived the requirement for professional training hours, so to speak, for the license renewal for this period. Of course, you still have to pay your fee and submit your license renewal paperwork and everything. ADEQ did not waive the requirement for the training hours, the 24 training hours for this licensing period, but they did extend the deadline to acquire that training to December 31st instead of June 30th. So that's going to be nice and helpful. So we'll definitely keep having some meetings to give people opportunities to acquire those hours. So as we've done in the past, we'll still submit training hours for people who get us through attendance records for today. We'll submit those to ADH. And just something a little bit different, remember that ADEQ does not allow the district to submit individual training hours on your behalf to them. So we'll still log the training on our website in the spreadsheet as we've done in the past. So you can go back and reference that. But ADEQ, as you recall, I have that form somewhere. They have their form that you have to fill out and you have to submit with your own signature and information. So, and Zach, just stop me if there's chats or anything that I need to slow down and address. So,
oh, you're doing a good job.
Okay. Let's see. So please, as much as we would have loved just to take the attendance directly from the Zoom attendance roster that's kind of logged for us, that doesn't give us all the information that we need to properly track your hours. So in the email that we sent out yesterday, there should be a form like this in here. So any of these virtual meetings that the Northwest District puts on, please fill this out for your organization. So Springdale Water, if you have a bunch of people from Springdale Water attending, list all their names, their training ID, and have the individuals sign it. And once you get everybody that's attended, then please have the appropriate supervisor or manager kind of give a final sign off and then email it up here to our district. And then we would get that on the spreadsheet and on our website as we've done in the past. We'll submit that to ADH as well, so for paid members. Yep, Zach mentioned that this meeting's been recorded. We're going to try to post that on the district website for probably about 3 weeks. It'd be nice if you could give us a couple days to get it posted there, but that way for people that couldn't be here today, there's a lot going on, juggling schedules, weather related issues, they can still have access to the training. And ADEQ said that that was permissible for people to watch the recording and just fill out the training log if you'd like us to track it with everything else. So financially, hope I'm not going too quick, but trying not to drag this out for everybody. Just letting you know how the district stands. Kind of the treasurer's report for the Northwest District for the January report that kind of goes through half of December. You can see we started in October with a balance of $26,128.40, and on December 10th we had $25,650.06 still in the Northwest District account. Keep in mind that that is a pretty decent amount. That does not include, we have roughly $5,500 of Water for People donations that we still need to release to Water for People. We're kind of awaiting instructions from the state AWWWEA on how they prefer for us to do that. But and then there's a couple $1,000s for scholarships that is also not reflected that will come out of this number. So, and I don't know how this might be possible, but I think formally and technically, I'm supposed to have a motion and a second to approve this treasurer's report as presented. And if there's any objections, just put that in the chat as well. So that may have to get creative on how we make that work, but let's see here. What else?
Oh, hold on. We got a motion to approve. We got a second in the chat.
Great. Any objections for the? Okay. If there's some objections, we can address those. But.
I've got a second from Ashley Gregg.
Great. Thanks. All right. Well, we'll keep moving here. Almost wrapped up. And then we'll hang on for a little bit after in case anybody has any other questions. But so we're going to have additional meetings throughout the year. We don't know those dates right now, but we'll email everybody and post that on the website as we get those scheduled. Also in the email from yesterday, just remind everybody that if you paid your Northwest District membership dues in 2020, then we are waiving those dues for 2021. If you didn't pay in last year and you wish for us to track and to submit any of your hours, then we will probably by next week. I don't think I have it ready yet, but we will attach a membership form and put it on the website so you could submit that and get you in good standing. And also, if you've had a lot of turnover in your organization, you need to add some people to your organization that we track, then it might be a good idea for your organization to download a form. And of course, if you paid, don't worry about the payment, but at least submit the new names with training IDs, and so we can add those to the list to track. So, yep, I think the last thing that I really had was just due to COVID last year and not really knowing how things were going to work. The Northwest District Board voted just to keep the officers and members the same for 2021. And we'll get through this year, and there will definitely be changes in 2022. So I can promise you that. But all right, does anybody have anything else that we need to address or any questions?
I motion Mayo Miller, permanent president forever.
Denied. Absolutely denied. So no. Well, if there's not anything else, I'll stop my share here and make sure I didn't miss anything. If there's not anything else, then we will go ahead and close this meeting. But we will, Zach and I and Austin will hang on for a little bit in case anybody has any questions or concerns. But thanks, everybody. Be safe. Have a good day. And stay tuned for more communication.
Thanks, everyone.
Thanks, guys.